are recording. Now I'll share my screen. Awesome. Great. And I'll move this over here. Okay. So you should have Git pulled by now. And this is what you should see. We have the markdown file like normal. And today's topic is working with Postgres through Python. And then also, as part of it, using CSV files. So we've seen those little comma-separated value files, things like this. I just have an extension to color it, but that's all it is, just things followed by commas, followed by things, followed by commas, eventually a new line. And how to use those CSVs as your means of seeding a database, as in inserting lots of elements into the database without doing it so manually. So that's the topic of today. Basically, we've learned how to use Postgres through using SQL. And we've done a little bit of that with these .SQL files because that made it so we weren't just typing it all in. We could have some kind of record of what we did. But ultimately, we want the power of a programming language to really be able to keep ourselves from repeating ourselves unnecessarily. So yeah, those are the topics for today. We're going to be talking about this library scopg. Don't know why it's called that, but this just happens to be the library that lets us interact with Postgres from Python. And it lets us do this at a very basic level where we can just write queries directly. Eventually, we get to something even more powerful than this called an ORM, which means Object Relational Mapper. It's this idea where you, in a language like Python, instead of working with just SQL statements, you're working with objects now that represent, a row or a table or something like that. But we haven't gotten there yet. That's something that Francisco will get to you with, I think, this week as part of Django. Perhaps not. But for now, we're just going to work with SQL as directly as we can in Python using this library scopg. And part of what we're also going to discuss today is this idea of a SQL injection. So no one expects anyone coming out of not just a boot camp, but in a CS undergrad program, no one expects anyone at that level to be able to really know much about securing a system. But there's a few like super common forms of attack that it's good to know about because merely knowing about it will wake your mind up to how a hacker might think and how you need to be careful about things. So now that we've introduced SQL, we're going to see what a SQL injection is. And I think you're going to like that a lot because it's very clever. It's very you really see how, the computer is not smart. It just does what you tell it to. And if you're tricky about it, you can tell it, someone can tell it to do something different than what you might have intended. And then finally, we're going to talk about using CSV files like this Sacramento file to seed a Postgres database. Okay. So, and I'll say this is a class where, for the most part, you should be following along. I have in this folder scopg examples, we have examples at various stages of things that, reflect what is in the markdown file. But I'm going to rebuild it in this empty file, scratchpad.py I made. You can make your own. But that's just to show you, this is something you really can code along with us, which will help you understand it. So yeah, to introduce this, as we've said, we've been working with SQL for a little while, and we've done that in a few ways. One way that we did that was we would go into our terminal like so, and we could just say something like, TSQL, and then what are some of my databases I've already created. So maybe I'm going into, let me go into a simple one that I've seen that, doesn't have too much going on. So let's say I went into my database that I called Grubhub, From there, I might say, I want to look at what my tables are. So I have a table called like order, or let's just say users. And that's what my user looks like. It has a user ID, which in this case is an integer, but no, it's serial. So it's just going to automatically make the next value. And then I have a name, and then I have a created at. And, I can look in there and say like select star from users, and I have one in there, or I could say like insert into. But it's not really important what we actually do with it. What's important right now is I'm showing you this is how we're interacting with it. We're interacting with it directly in our terminal, which is great. That's definitely, the ultimate source of truth. We're interacting with PSQL directly, but it's not so useful in terms of like holding on to your work and recreating it, which is why eventually we created a .SQL file. So let me just go back to where we actually are in the curriculum. I'll say uniform curriculum, 5 SQL day 4, and I'll just make the file here. So I'm going to make a new file called, I'll just call it SQL script.sql. So this is a different approach we made to working with SQL, where we have like a kind of script. And in that script, I can write the same commands that I would write in the terminal, but I can keep track of them now. So let's say I had that users table. Well, I could say something like, well, I actually want to change what the user table is like. So I'll say drop table if exists users. And then after that, I might say, is it create table? I always forget my syntax. Create table users. And what does that look like? Well, it's going to have an ID of serial and like primary key. And it's going to have, every user will have a name, and it'll be varchar 255 and not null. And then maybe every user will have like a timestamp. Can anyone remind me how if I said like created at, what type do I want?
I think date. Timestamp.
Is it timestamp?
Or you can do timestamp TZ. Either
TZ?
one.
What's
That has the time
TZ?
zone as well.
Oh, interesting. I didn't realize that. Yeah, so let's say we also care about the time, the time zone. So yeah, that's a cool thing. I didn't realize that was another feature. So yeah, we'll have timestamp TZ. I don't know if I have to add not null there. I'm not going to, but anyways, this is what I want my table to look like. And after I make that table, I'm going to actually want to insert something into it. So let's say insert into, and we're inserting into users. And we don't need to insert that ID, right? Because it's going to be automatically incremented for us, but we need the name and created at. And then what values do I want to give it?
John.
Okay. And notice we're using, because this does come up later again, we're using single quotes. Because that's what SQL likes. SQL does not like double quotes. It does not recognize them as equivalent to single quotes. It uses single quotes for strings. Okay, so that's John Malkovich. That's our name. And then for created at, how do I do that? How do I do the current time? I know there's a way, and I know that someone in this class has shared it before.
Yeah, I think if you just on line 6, if you put after timestamp TZ, you put default and then current timestamp TZ.
Like one word or
Yeah, underscore.
like that?
I think you just don't have to pass it into the insert statement. It's
Yeah,
something
that would make sense.
similar to that. And you just remove created at as well.
I can remove created at? Oh,
Right.
here. Yeah, got it. Yeah, exactly. So I believe this is, you're right, this is how to do it. So just like the ID here, because we made it type serial, it's automatically going to be given a value. This is the generalized version default. So it's just going to be given a default value, and that default value is this pre-existing thing called current underscore timestamp TZ. And you would learn that just by looking this up on, SQL's website or Postgres's website. But as a result, we shouldn't have to include that either. So let's see that this runs. And the main reason we're doing this anyways is just to show like, oh, like I'm actually keeping a record of things now. I'm not just, writing it directly in the terminal. So how would I run this SQL script now to pass it into my database? So the database we want to work with is PSQL. What's the one we just used? Grubhub. Okay. So what do I do to work with this SQL script?
To just enter this and it'll put you into the Grubhub one, right?
If I enter this right now, you're correct. That would bring me into.
Oh, you're trying to put the file in, you were saying? I'm sorry.
I want to run this file against the database. Yeah.
Can't you go inside the database and use /i, the file?
Let me see. So I do /i, and then, oh, that looks like that does work. Yeah. And there's an error because it cannot drop table users because other objects depend on it. So it wants us to use that constraint thing. Okay.
You need to put cascade.
Yes, exactly. So it wants us to use cascade like that, I believe. So we could try that again now.
Oh yeah, we got that syntax wrong. It might be current timestamp instead of timestamp TZ. I
Yep.
haven't used it with timestamp TZ before. I'm not exactly sure what this.
We could always look it up, but this is the whole reason why you run things. Okay, it looks like that worked. And now if we said select star from users, we would see we have one person in there, John Malkovich, and this long created at string, which implies a date and a time, and then maybe this is the time zone. I don't really know. Maybe it's milliseconds. I don't fully understand it, but we did add something. So yeah, exactly. That would be a way to do it. It's good to know about that /i thing. I'm going to do /q to quit. And another way to do it, which is the way I'm more used to, is we say pSQL Grubhub. That would normally bring us into that database in PSQL. But then we could use this redirect operator. And that redirect operator, you look at it like an arrow, and it's saying everything in the right, I'm going to pass it into what's on the left. And then in that case, I could actually take that SQL script. And now I'm saying run that SQL script inside, like pass that SQL script as text essentially to PSQL Grubhub, which will then know what to do with it. And indeed, it works the same way. Cool. So that's what we've covered so far. Any questions about that?
Hey, Ben, what was that line that you changed for the timestamp? Did you take out default, or what did you take out?
Yeah, so we kept timestamp TZ for the type, and then we kept default. But here, where we gave what the default is, the built-in thing is called current timestamp. We were trying to do something called current timestamp TZ, and that doesn't exist apparently. So this is what we wrote. We took out the TZ at the end of current timestamp. And I'm pretty sure if we search for that, we'd find it all. So if I look at PSQL timestamp TZ, it's always a little difficult to read this stuff, but we would find all the details here somewhere. So if I look for timestamp TZ, no, that's not quite coming up. Oh, there it is. Okay. So the SQL standard requires that writing just timestamp equivalent to timestamp TZ is accepted as an abbreviation for timestamp with time zone. Got it. And then that default thing is just what am I looking for? There, the default. You can give a default of timestamp. I'm better with examples than I am with docs like this. So that's often why the official docs are a little less useful to me than something like this. This website is probably gonna be a little better because it's going to show me some examples. So right, exactly. And then I'm sure there's a place where they show using the default. Maybe not. Okay, that's probably enough for right now. But yeah, it's all built in. It's just sometimes hard to find out exactly what things are, and that can be annoying. But yeah, that's why learning something and remembering it can matter, because Googling is not always so effective. Like, I'm not seeing the stuff about default here. I might not have been able to learn it myself. I might have done it a different way as a result. There seem to be some built-in functions like time of day, which would get you, or like now, I believe would give you the current time. So something like that could probably work too. But regardless, we have this SQL script here. And that's going to help us build to the next level. So any questions on this before we move on to the next level?
Sorry, would you mind kind of briefly going over the cascade keyword and like why that fixed the issue that we were just having?
Yeah, so in truth, I don't understand it super well, but the thing is, the problem is that the users table already existed. And if we go in here and we go into our PSQL Grub Hub, and I say /D, I think I'll see there's a bunch of things here: users, user ID sequence, which I don't think we have to worry about that. I think the nature of that is that because we have a primary key, there's this thing called a sequence, which is keeping track of things in a certain order. But we're just going to look at the other thing, orders. So if I said like /D users, I would see this is what a user is: an ID, name, created at, and then this index, which I think relates to the sequence of, you know, it named this stuff for us, but users p key relates to this ID, and it's the primary key for this user. But now if I look at orders, I'll see that actually the nature of orders is that it has an order ID, but it also has a user ID. And I don't quite see it here, but at some point we linked them up to each other so that user ID references, you know, the primary key in users. And so the problem is that when we try to delete users, if we just try to drop the table users outright, SQL is telling us, and we can try that right from here. If I say drop table users, so I'm not saying if exists or anything, I'm just saying drop table users. It looks like it dropped it that time. Okay, I think that, I wonder why that is.
You think when you dropped it the first time and used Cascade, you changed the values of it? It's probably like completely different than what it was before.
Yeah, that is probably true. So let's just try that. Let's say I say drop table orders. So we don't have an orders table at all anymore. And if I go like that, there's nothing in here. So the first thing I'm going to do is I'm going to say, maybe I'll run this code again so I can have my users back. So I'll say like that, and then I can do it right from here, which is really cool. Okay, and now if I look at users, so if I do /D users, I see that it's there. And if I select star from users, it's there. That's my users. But now what if I wanted to actually create some this other table? I wanted to create an orders table. So I'm going to go back here and I'm going to take out this cascade for now. It's just drop table if exists users, and then I inserted one thing into users. And I'm going to make another table over here. So I guess I don't need to copy it. I'll just do drop table if exists orders. And then I'm making a table called orders. And I think orders will just have a normal ID for itself. So this represents the ID for the order. But then let's not even worry about what the order keeps track of. Every order is associated with exactly one user, right? So how do we do that? How do we make it so that the order references the order holds a foreign key that references the user's primary ID, primary key. So I'm going to make something like user ID. What do I want the type to be? Or just how do I want to do this?
Integer.
Yep, integer should be fine because serial is just an integer that knows to auto increment.
And then you can just do references, user parentheses or users present. What is it? Is it plural or is it singular? There you go. And then ID.
I named it users. So yeah, so users ID, and then that's it, right?
Don't you also have to put not null off the integer?
It's a good question. I mean, we could try it out. As in, if I do this right now, my first question is, does it work? So I'm going to try and insert that into here. And then for orders, let's also insert something. We don't need to insert the ID, but let's say we insert the user ID, and I'll just give it the value of 1, because that's going to be the value of this single user that exists called John Malkovich. So let's try running that. We can run it again like this. Doesn't seem to like it. It says table orders does not exist. Error, syntax error at or near insert. I'm assuming I didn't. No, I have a semicolon. Okay, so what did I do wrong?
Not after, you don't have one after creating the orders table.
Okay, yeah, there we go. Yeah, oftentimes missing the semicolon is the issue. So let's try that again. Great. So now in here, I could say select star from users, and I'll see all my users, and then I'll say select star from orders, and I'll see my orders. And as you see, this has an ID of 1, and this has an ID of, and this order happens to be the first order, but it's pointing to a user with ID of 1, which is John Malkovich. So if we decided to write a join statement, I could say select, maybe I would say select, I guess I would just say select star from, and I would do it from users. But then I would say select star from users. How do I join this with the orders table? What's the keyword to start pulling them together?
Join, inner join.
Yeah, so I wonder if just join would work, but let's just do inner join. And the only difference between inner, outer, left, right is whether there's any nulls. So we don't need to worry about that right now. So I'm going to inner join it with what's the name of my other table? Orders, right. So I'm joining users and orders, but I have to say how I do that, right? So the next keyword is with, right? Or on, I believe it's on. Yes, we're going to join on. So we're joining users with orders and on some relationship. So what is that relationship?
Would it be user ID? Something, I don't know how exactly to spell it out, but.
Well, we're trying to relate. So let's say we're going to start with orders. Orders has something in it called, like, what's the relationship between the orders and the users table that we want to combine them on?
Did you set their ID?
User ID equals users.id.
Exactly. So we're going to say orders has this thing called user ID, and anywhere where orders user ID matches exactly the users table .id field or column, when these match, then I know I want to join them. So if I do this, it's probably going to look a little funky, but this has all that information together now. We've joined them based on that relationship. So that now brings us, I first want to answer the not null question, and I'm going to answer it by seeing. So the question was asked, for user ID, shouldn't I have to say not null? Well, maybe. The question is, let's say I tried to insert another order, and that ID is going to be automatic. But let's say that user ID, I just gave it the value of null. Does that work? Let me try that. And in fact, I don't have to, I can just write this as a new line in my PSQL. So let's try that. Yeah, that seems to work. And so if I select star from orders now, it looks like that. And yeah, that's a bit of an issue because now if I try and do this join thing, the inner join is going to ignore it. But if I did like, because the inner join ignores anything that isn't it ignores anything where either side has a null in it. But if I said select star from users, I think if I said left join, in that case, as long as it existed in the left table, it would join them. No, maybe not. If I say full outer join, yeah, now we have our issue where because I'm combining everything regardless of null, I am matching that first ID to that first order ID. So I'm matching orders user ID to the ID in the users table, and that gets me, this full thing. And if we had details about the order, we would now know them related to John Malkovich. But we also have this sort of blank nonsense thing. So that is where we would want to use not null. So whoever said that, you are right. That would be the right thing to do. If it doesn't make sense for an order to have a null user ID ever, we would want a situation like this. So now, if I run this script again, first it's going to break because it's going to say failing row contains 2 null, so it doesn't like this last line anymore. So we're going to take that out. And then we're going to do it again. And that seems to work, but I was, yeah, so we do, that seems to mostly work, but we do have a problem here. A little hard to read, but basically there's a problem because we're not cascading things. That's the reason we started talking about this. So even though we ran this code, it didn't actually drop the table users. So let's say I changed it here. Let's say I said, okay, that first user I'm adding is now not John Malkovich, but Johnny Carson, right? So I'm thinking that when I run this, I'm dropping the user table, creating a new user table, and then adding this value to it. But in reality, if I run this right now, because it did run all these different things, but it didn't actually drop the table users because there was some issue. And now if I were to look at what my users looks like, just get that, let me just get users. If I look at just what my users look like, well, we actually added things multiple times because we were never dropping the table each time. So what is the actual issue? The issue is this cascade thing. The reason there's an issue is because it's trying to drop users, right? It's trying to drop users. And when it drops users, it drops the whole table. And that seems fine because there's nothing in users that references anything else. But turns out, still existing, because this is run in order and it's run against the database. Well, while this is running, this drop table if exists users, there currently exists something called orders. And orders references users. So what that means is that, let's say I drop the table users. Now the table users has nothing in it. Well, that means that everything in orders with this user ID referencing user's ID is now nonsense. So if I go back here and I look at all my orders, I only have one, but if that table doesn't exist, then this user ID of 1 now points to nothing. And it doesn't like that. It's trying to warn us saying, I'm not going to let you drop table users because, and it's hard to read, but other objects depend on it. Constraint orders user ID F key, foreign key on table orders depends on table users. And if we did that /d orders we would actually learn some stuff. So this is all behind the scenes, which is why it's hard to think about. But there actually is this constraint with a specific name, order user ID F key, which they made for us. And it's a foreign key constraint. It's associating something in our table called user ID, which we wrote ourselves, with the users table's ID column. And so because it relies on users, we can't delete users before first deleting orders. So one thing we could do, get rid of that. One thing we could do now that we're just in P-SQL now. So I could actually say, okay, well, the first thing I'm going to do is to drop the table orders. That works fine because there's nothing, I can drop orders because nothing else is referencing orders. And now if I try to drop the users, that works fine. So that's one way of doing it. But it's not the best way of doing it because now the order in which I do things matters. So if I come back here, I might say like, oh, let me just move all my stuff about orders on top of users. Instead of doing that, we have this keyword called cascade. And what that's going to do is say it's going to drop users, but before it drops users, it's going to check what relies on users. And anything that relies on users will be destroyed. So I believe that if I do cascade, I'm not sure if it deletes the whole orders table or it just deletes every row in orders, because every row in orders will, reference the user table. But either way, I'm making it so that anything that would prevent me from dropping that table because something else relies on it, I'm just deleting all the things that rely on it. So it's more powerful and therefore more dangerous. But this is more often when you're just testing things out, and that's why you're usually using one of these .SQL files. You're going to use that cascade just because it allows you to not have to think about the order when you're creating things, because you're just destroying things in order to recreate them anyways every time you run the file. So now if I run this, I imagine it will work as expected. Yeah. Yes. So does that answer the question about why we use Cascade? And it looks like Robert shared something good in the chat.
Hey Benjamin, when you were saying earlier, when you're joining tables, what is the left and right table?
Say that one more time.
When you were joining tables, which table is left and which is the right? Is it the first and the second?
Yeah, that's a good question. So let me get that line back up. So I believe left is whatever is in that first from, and right is whatever is the thing after the join. So I think left and right are determined by which one we chose. So if we wanted to test this out, I might want to first create something like, I could have something like here where I wonder if I'm able to, like, in this case, I said insert into users name, value, Johnny Carson. Would I be able to insert into users something like not just name, but also ID and give it null, or it wouldn't allow that? I'm not sure. So if I really want to test this, I'm going to want to do that first. So let me see if it'll allow it. So it doesn't allow it, but just for testing purposes, I'm going to remove this serial thing or the primary key, just because a lot of that is there to prevent things like null. But just to see the left and right join thing working, I'm going to say, okay, well, this is just an integer. And as a result, it could be null. And similarly here, this, yeah, I guess similarly here, user ID integer can itself be null. And this is just going to be an integer, no primary key, and it could be null. And now as I have this, I'm going to say, okay, well, insert into users. Let's say I'll say, ID and name. So Johnny Carson will be 1. But then I'll also insert into users something like ID and name null, who is someone else. I don't know why I'm always doing actors. I think that's a person. Okay, so I'm going to try both of these, and then I'll also insert into orders. So I'll put that ID there, and the ID will be 1, and it'll be associated with the first one. And then I'll say over here, the ID will be 2. And what user ID is it associated with? It's actually going to be associated with null. And because I didn't do any of these not null constraints, this should work. So let me first do that. Let me get this in here like that, see that it works. It might not. Relation orders does not exist. Where did it go wrong? There is no unique constraint matching given keys for reference table users. So it wasn't able to make the orders table, seemingly. Maybe because I didn't make this a primary key. So maybe I do want to keep primary key in there. Even though I'm not saying not null. So let's try that again. And this is just to show Yeah, I mean, this is I feel like I'm getting in the weeds too much between the join stuff in terms of null and not null. This is probably not worth our time. If I go back to how it was, let's see. Let's say I have my users like this. I have my orders like this. Is there any way the user ID could be null? Yes, it can. Okay, so I'll do that. And so maybe I'll do this. I'll say I have a user with a given name like Johnny Carson, and then I'll have and that should work as expected. And then I'll say I have an order whose user ID is 1, and then I'll also have an order with user ID of null, and that should all work. Let me just see that that works. Okay, so now I have all my orders like that and all my users like this. So now we could actually see the difference between these joins. So the only thing that is null is the second row of orders with user ID. So now I could say something like, if I said select star from, if I started with users, then, you know, this would be all of my users, but I'm going to say users, and then I'm going to do a join. So I believe if I did a left join, it would always put something in as long as the thing was in the left table, which is users. So if I try that and I say left join, and I'm joining with orders, and I'm joining on orders dot user ID is equal to users dot ID. So let's see what that gets us. If the thing is in the left, it will match with whatever is in the right. So we only got one thing there. But let's say I said a right join. I think a right join would say, let's see. Yeah, a right join now is going to say, it's going to start with that right table. So that right table is my orders ID, and everything in there, as long as it's in there, it will try and match it with something on the right. So in this case, we have a user ID. It's empty. It's null. It attempts to match it with something on our left, which is the users table, and there's nothing there. So we just get a kind of dummy row. So that would be the difference between left and right. And I believe that would change, the behavior would change if I move these. So if I said right join users, and then I set up here from orders, I believe we have the inverse behavior now. Yeah. Where now left represents orders and right represents users. So yeah, that's it. Left implies the first thing that you're selecting from. Right implies the thing you're joining it to. And whichever the join is, if it's a left join, it means as long as it's in the left column, even if it's null, I include it. Right means as long as it's in the right column, even if it's null, I try and match it up with the other table. Yeah, we're going to get to psychop-G. We just got a little distracted by questions, but they were good questions. So how about this? I'm going to give everybody let's give us a 10-minute break. You know what? Actually, no 10-minute break, because we've only been going for 40 minutes now. We're going to go for another like 10 minutes, and then we'll take like a 10-minute break. But these were all good questions. It is good to clarify this stuff. But coming back here, the whole point of showing the .SQL stuff was to say, like, yeah, we've used that before. Create schema.SQL, see table.SQL, and that's great. .SQL does help us a lot, but something it can't do is like variables. So I can't say like, I can't do something like for, values in, one no. Like this, if it was Python, I could write something like this, right? For values in one null, or maybe for value in one null, insert into orders value. So if it was Python, I could do something like that, but I can't do that in SQL because SQL doesn't, it's very specifically designed for data querying, but it doesn't have this concept of variables. It doesn't have the concept of functions. It doesn't really have these various data types in terms of how we use them in Python. So SQL is not really a programming language. It's what's called a declarative language. You say what you want, you describe what you want, and then it gives you what you want. But you're not able to you're not able to say do this, then this, then this in the same way you can in a language like Python. So in that case, how do we get that behavior? How do we get things that would be useful, like variables and functions, for the sake of working with our SQL data? Well, in that case, we use a library to connect SQL or PostgreSQL to Python. And in that case, we use a library called psychop-G. So this is the link, I believe. I'm not sure how often. No, the link changed. Okay, yeah, I noticed that last time. Yep, so I will update this link, but it's not so important. This is just the link to the actual library, and the current version is psychop-G3. So when we install psychop-G, that is actually psychop-G3, as we'll see. And then you can go into the documentation, and there's lots and lots of documentation that one might want to learn about. But we're going to cover all the essential stuff. Okay. So coming back to here, this is psychop-G. So let's actually do this at your end as well. We're going to create these databases. So I already have this database, but I created a database called psychop-G-test. And if you want to create a database with a different name, that's fine. But this database already exists for me. The idea is we just need to make a database for what we're going to be working with, because we need to reference it in when we're working with psychop-G. So if I were to say PSQL psychop-G test, I already have that database, and I have some stuff in there, which is the stuff we're going to be working with, but I could easily just throw it all out because we're going to be using psychop-G to recreate it. But that is the name of the database I'm going to be working with, so I want it to exist. And now coming back here, after we create that database, in this case, I wrote a file called students.py, and I happen to put it in psychop-G examples, but where it is doesn't really matter. And I'm actually going to just do this stuff in scratchpad.py. So in scratchpad.py, the first thing I would probably want to do is say import scicopg. So this is actually seemingly working for me because I've already installed it. But we might want to install it ourselves. So we would do it like pip install scicopg. So coming back here, I could say pip install scicopg. This is going to say I already have it. And if I said pip list, that would actually show me everything I have in my Python virtual environment now. And if I looked for scicopg, I would see that scicopg references this 3.1.9 because it's version 3. I already have it. But notice that if I look on the right here, I'm in my default Python virtual environment. And all of you should have that also set up because of how we set up the install fest. So we have a Python virtual environment that is, you know, for me, it exists at my root level. And then in .zshellrc, it's being activated every time I start my terminal. But it is worth covering that for specific projects, you might not always want that. So if I go into scicopg examples here, you'll see I have something called scicopg-venv. Well, I'm actually going to remove that. So I'm going to remove that so I can show us doing it. And these are the next steps that are over here. So I am going to install this, but before I install it, I'm going to show you, well, what if I wanted to create a virtual environment just for this project I'm working on? So first I go into the folder I care about, and that's where I am right now. I'm in the folder scicopg examples. And then I'm going to say, well, for this whole folder, I want to have a unique Python virtual environment. So I'm going to say python-m venv, and that will let me create a virtual environment. And then I can name it whatever I want. I'm going to call it scicopg-venv. It's very common, actually, that people just call it like .env, and it's just for that project. And that way it's hidden. I can show us doing that as well. So if I said .env, now it's a hidden file, but it's local to this environment or this folder. So if I do that, I could actually see it. It's right there, .env. But you'll notice that my default is still my environment. So at that point, I have to say source. And then I actually have to go into that .env, go into this bin folder, and then there's something called activate, and that's what I run. And now I'm in this new virtual environment, which I called .env. And now if I were to say pip list, what I would see is there's very little in there. And that's the whole point of this virtual environment thing, that I might, in the case of using that default virtual environment, every time I install something, I'm installing it for basically every project I work on, which means if that project, if I ever wanted to share a list of dependencies for that project, I wouldn't know what's specific for that project and what's just, you know, for another, like that I used it for another project. And you could run into issues with like versioning if you use different versions of something for different projects. So the ideal way is you just have a unique environment per project. And then you have to remember to do this whole activation thing. But once I do that, well, I see here, this is my current environment, .env. And now if I were to go back to my Scratchpad, well, I'm doing import scicopg there. Well, will that work? If I say Python Scratchpad, it doesn't like it. It says that there is no module like that. And that's because if I say pip list, I never installed it. And that's why now, given that I'm in this virtual environment called .env, I can say pip install scicopg. It will install it uniquely for this environment. So now I could say pip list, and it's there, including maybe some other things that it needed to install it, because scicopg had some of its own dependencies. And now if I run that same file, it works. We don't see anything, but it works because it knows about that library. And I would say that's enough for right now. We're going to come back in 10 minutes. And when we come back, we're going to start showing what it actually looks like to work in scicopg. So just as a just as a taste, it's going to look something like this. So this is like a very minimal thing here. All we're doing is connecting to a specific database. We're creating some query. We're running that query. We're committing that query. We'll talk a little bit more about this as the lesson moves on. And then we're closing the connection to the database, just like when you open a file, you have to close the connection to the file at the end. But we're going to discuss that when we come back. So let's come back in 10 minutes, which would be 9:05 my time, 10:05 CST. See y'all then.
Hey, Ben, I had a question.
Sure, yeah. I just want to say quickly, if people, when we go on break, please do take the break if you want to take the break. I will stick around for answering questions, and these questions will be recorded. But I don't want us to get into a situation where we ask lots of questions during the break, and then people feel obligated to stay during the break, and then we have to give a break after the break because no one took a break. Does that make sense? But go ahead, ask the question.
Why are we creating a virtual environment? Why can't we just install these dependencies in our a working environment?
Yeah, so I see it looks like I lost a lot of people on the virtual environment stuff. The answer is you don't have to do it this way. You don't have to do it this way. It's only to show you that we're going to start doing it this way more often, because the nature of projects is that you kind of want to keep your projects separate, because it could be that I have one project that uses just psycopg as a dependency. I have another project that uses just Django as a dependency. I have another project that uses psycopg, but an older version of it for some reason. And I want to keep all those separate. And the problem is that if they're all using this same virtual environment, they can't, as in they all reference all of those things. So the project that only uses psycopg would actually, if I were to create a list of dependencies for it, it would think based on the environment that Django is a necessary thing to download. And similarly, for the Django one, it would think it needed psycopg even if we didn't use it. And then we actually have no solution for the one that uses an older version of psycopg, because you can't have two versions of the same project living side by side, because how would it know when you say import psycopg, how would it know which version you want? So the whole idea of a virtual environment is so that these dependencies can be specific to the project. But for the purposes of testing things out and learning, it's much easier to just have a general default environment in which you're just downloading everything, because it lets you play around with things. And it might have been overkill to show the virtual environment stuff right now. It's just that was already in there, so I felt I should.
Gotcha. Okay. Yeah, that answers it. Thank you.
And I'll talk about it when we come back. Cool. See everybody in a few minutes. Everybody, I think we're ready to come back. I see in the chat some people felt a little confused by the Venv stuff. That's very fair. It's not essential to this lesson. It just was in the lesson already, so I thought I would include it, but that's why it's in this little, section implying like optional. In reality, it's fine to stay in the default environment and just install scicopg. The Venv stuff is stuff we will continue to talk about because it matters for kind of separating your projects from one another, but it's really not essential at this stage. So I'm actually going to close my terminal entirely. And when I reopen it, you'll see I'll be back to default because that's how I set it up. And if I say pip list, I still see that scicopg is there for me. And you could just install it at default and that works fine. And now I'm going to go back to uniform curriculum and day 4 and these examples. Make that a little bigger. And then from here, if I were to say Python Scratchpad, I would still have no problem because it is installed. And that's all that really matters. So other than the Venv stuff, are there any questions before we move on and start talking about working with scicopg as a library? Okay. I hope that is a good thing.
So are we just not going to use the virtual environment then? Just exit out of it?
Yeah, essentially. I mean, hopefully you have it set up like this, where what I just did was I just closed my terminal and reopened it, and I'm back to the default virtual environment. So you're always in some virtual environment, or you should be when working with dependencies. But this default one, I have it so that, if I look in my .zshellrc, that's where I have it set up. I guess there's a bunch of stuff here. But this default one just says, okay, when you start, look in the home folder for something called default bin activate and run it. And indeed, if I look here, if I were to look at, ls, my home folder, I have something called default in there, and that represents my default virtual environment. And that's where all my dependencies are being kept track of. So you do want to be in some virtual environment, but let's just stick to the default virtual environment. That's where we're installing everything. If anyone has a problem with that, let's discuss that now. Otherwise, it shouldn't matter, and the Venv stuff is not super necessary for today, so we shouldn't spend too much time on it.
Yeah, I just want to mention, if anyone's on WSL, I don't think we have a default folder in our root, and I don't think it functions the same way.
Well, that's not that was something that was part of InstallFest. That's not built in.
Okay. Was that just for Mac? Because I don't have a default folder in my root, but I followed the InstallFest.
Yeah, I think a part of the issue might have been that it was part of the modern InstallFest, but I think some links were a little messed up or whatever it was. I noticed a number of people during InstallFest were looking at Tango's InstallFest, and it wasn't in that. But it's pretty straightforward. It's exactly what we just did, in that if we're going to spend a second on it, basically you go to your home folder, right? You go to your home folder, and the first thing you do is you create something. So I created something called default. It's already there, but let's say I wanted to do this again. I would say Python -m venv, and then anything after this would create a new virtual environment. It wouldn't move into it. It would just create it. So I could call this my default environment. So this is the first thing you would do, and you would do this exactly once on your terminal, and you would want to do it at your home folder. So I wait a second, and now I have it. So I have something called my default environment, and it's at my home folder. And if I go inside of it, I could start to explore it. I see there's some stuff in there. I could go into bin, which means binary, and I'll see that there's a bunch of stuff in there again, including a script called activate.
Okay, well, yeah, I can do this later. I don't want to hold everyone up right now on this. I can do this later.
Okay, we can definitely discuss it later. The main thing was just that if you want it to choose that to activate that default environment every time you start your terminal, you're going to want a line like this in your Z shell RC or in your bash profile, whatever it is that runs automatically when your shell starts. You're going to want a line like this that just activates that default environment by default. But yeah, we can discuss that later if some people do not have that. Let me just quickly remove the thing I just created. Okay, so I'm going to go back to where I was here. And we're working in this scratch pad right now. So let me open this stuff up side by side. I'm going to have the scratch pad over here, and I'll have this over here, let's say, so we can look at them side by side. And then I'll open up the terminal over here. Gets a little hard to see given how Zoom is. There's a little too much on the screen at any one time with Zoom. But yeah, this is where I will start writing the code. So on the right here, as we see, we have some stuff. So the first thing we do is we're importing scopg, right? We're importing that library. I'm looking in the chat right now. I see people are still talking about the virtual environment stuff. This is definitely something we can go over in the afternoon or something. If you don't see it on your terminal, it doesn't mean it's not activated. It's just my terminal is fancy and knows about it. Yours might just not be displaying it, but you're still, you know, in that virtual environment. But we can go over that this afternoon. As long as you can pip install and then import scopg successfully, then we can move on. And if you can't, let me know ASAP. But as long as we're able to actually use this, and we know we can use it if we can just, you know, as long as we can type Python scratchpad.py. Oh, I should go into the file. As long as I can write Python scratchpad.py and it doesn't break, that means I'm in an environment that has scopg in it already. Okay, so the first thing I do is important, and then the next thing I do is right here. I'm going to connect to the database. So we're going to store it in a variable called connection. We're going to take that scopg library, and it has something called .connect on it. And .connect is going to take an argument that looks like this. We say DB name equals, and then the name of the database we're trying to connect to. And that's the name of the database that up here, I said, let's create a database with that name. So it could be whatever database you want, but it needs to know which database you're trying to connect to. Just like if we were in PSQL, we'd say PSQL, you know, scopg test. So this is the same deal. I'm giving the name of the database I want to connect to. So that's what we do. We connect to our database. And then the next thing we might want to do is we want to execute a statement. But executing a statement, you know, instead of writing it all on one line, I could do it like this. So first, I'm going to actually make a query, and I'm just going to make it as a string. But multi-line strings are kind of nice for this because SQL doesn't care about white space, but you do as a programmer. Like, it's a little easier to read it like this. So I'm making a string here. And if I were to print this string, it's just a string right now. There's nothing special about it. It's just a string. But what I could do is I could pass that string to scopg like so. I could say, here's this student table, and I want you to take that connection, which the connection was established here. That's the database that we're talking about. We're going to execute this query, and this is the query that we're passing to it as a string. And then finally, we have two more lines, and those two lines look like so. The first one is connection.commit. We're going to talk more about this later, but essentially before we do this line, this connection.execute here, it built up a transaction. It said, oh, I'm going to create this table, but it hasn't actually committed it to the database. It isn't in line with the database until I run this line. And the reason for that is because this line is there to say, yes, that worked. We'll get into it more later, but for right now, it's just we add this connection.commit. And then finally connection.close to say we're done using the database, because just like with a file, you don't just want to leave it open because that causes what's called a memory leak. Somewhere behind the scenes, it's still, your computer's still keeping track of the fact that that file might be written to. And so we close it to say we're no longer trying to write to that database. Yeah, Roger's saying in the chat, it's sort of like git add and git commit. Exactly. So that commit there is to say all the changes we talked about up until now, we really mean it. Actually put it in the database. Once we commit it, there's no going back. It's in the database. Before that point, I could be like building up some things, and as we'll see later, I might be able to roll back just like git and say, no, I don't actually want to do that. So we're going to run this. But I can already see a problem. So I know that if I go into PSQL and I go into this table, which was, what was it? A scicopg test. I'm going to see that if I say, you know, select star from students, well, that table already exists. Don't worry too much about what's in it right now. But what that means is that if I now type Python scratchpad.py, it's probably not going to work. And it's going to say because students already exists. So my question now is, how do I fix this? Given what we have in our scratchpad here, how could I make it so that the table, that, you know, if the table exists, we drop it and then we create the table?
Yeah, you just add that to line 9. Why did you drop the line down? That's the same thing.
Exactly, yeah. And that's an important thing to note, that I could have made it a separate, you know, connection.execute, but really it's all execute is doing is taking text. And so I could have multiple things in there. I could say drop table if exists students semicolon. I could even have a space in there if I wanted. And I'll save that. And now when I run this, it's going to do the same exact thing it did before, but it's going to execute both of those statements. And so now it works. And if I were to go into PSQL, let's open that up. If I were to go into PSQL scicopg test, I won't have anything in there, but I would be able to see if I looked for students looks like what I thought it should look like. Oh, I see I'm missing something there. So I would rather myself give it an actual amount. But yeah, I can run it again. So once again, I can do that. And if I go back in here and I run that line again, I'll see that it looks like what I expect it to look like. And I actually wonder, based on what people said about this .i, can I do like Python and then the name of the file, or no, that's not going to work?
Just the name of the file.
Okay, so it wouldn't, but so then it wouldn't work in this case because it's going to say, I don't know how to work with a Python file. Yeah. Okay, well, good to know. So we can't do it that way, but as you'll see pretty quickly, we don't have to go into PSQL nearly as much now that we're doing it like this. So I'm going to open it up to questions about this basic thing right now, where we're importing the library, we're connecting to the database, and then storing that connection as a variable. We're then executing queries just as in string form against that database. We're committing to it, which you don't really need to understand now. We'll get into this more later. And then finally, we're closing the connection to the database. So any questions on this basic flow?
Sorry, I kind of missed it. How'd you fix it when you try to load it up and it tell you it already exists?
We fixed it by just adding this line in here, drop table if exists students.
Thank you.
And that's an important point, that there's nothing new. We're not introducing any new ideas really in terms of SQL. SQL is still SQL. We're just interacting with it using Python. And as we'll see, we can get a fair amount of usefulness out of that.
Is this industry standard when working with SQL, or like the .SQL seems a lot more efficient than working with the Python right now.
Well, you'll see
me.
pretty quickly that the downside to the .SQL is we can't use variables basically. And so we end up repeating ourselves a lot. So I would say this is, there isn't totally an industry standard because people fall on different sides of the fence. Some people like something like .SQL or scicopg, in which they're very explicitly writing their SQL directly. Some people prefer things that we're going to discuss eventually, like an ORM, which Django has, which is basically you work with objects instead of directly working with SQL, and it generates the SQL for you. But this is definitely a valid approach that you would see, and you'd probably see it more often than you would see just using .SQL stuff, because as you will see, .SQL stuff does not get you certain features that you get when you do it like this. Any other questions about this? Or should we move on to like seeing some of the, some more of the power of this?
Are these like written all at once and executed at once?
Say that one more time.
Are these executed at once with like everything? Because it's already written in the students.py. Are we supposed to comment out and run each one at a time, or just run it all?
You can run them separately. If that's your question, it could be something like this. So we're going to see that in a second, but like this represents this one query, right? Creating the table. But I could just write a different query where I say connection.execute, and then maybe I just put it directly in there like this. So this would be the equivalent of what I did before. Now I'm running this line, and then afterwards I'm running this line. And then finally at this line, they're both happening in the order in which I set them up. Was that the question?
Yeah, for the most part, I was wondering if we could run a whole file as is with all the execute statements, or it would rather be like one at a time ran.
It doesn't really care. Like that execute is going to take a string, and that string could have 1,000 SQL queries in it, all separated by semicolons, or it could have just one. It doesn't care. It's going to execute is just your means of running SQL from Python.
Thank you.
Cool. So if I keep going through this, I see that should be updated. So now we're going to get into this idea of parameterized queries, which just means using variables to make our SQL a little better. So I'm going to copy paste all of this. It's going to be very similar, and then we're going to walk through it. And in fact, we don't need to look at both of these at the same time. We'll look through it like this. Okay, so once again, I'm importing scicopg. And then I'm setting up the connection to the specific database I want to connect to. And then I'm directly executing a statement. In this case, I'm saying if there's a table called students, drop it. And I should actually add a semicolon there. Or alternatively, I could do it like this, where I create a statement, and it's a longer statement. So maybe I want to do it like this, and I give it a name. I store it in a variable, and then I execute from the variable. There's no difference. It's just two different approaches. And then at this point, I might want to say, okay, well, I'm going to insert into, right? So I could just execute this line like this. I'm inserting into students, name, favorite food, values, Alice, cake. And that could be one line. That could be two lines. It really depends. That's just style. It's up to you. But this totally works right now. And you know what? I'll comment out all of this for now so that we can see that. We can see that that works. Comment this out. So right now, all that's happening is that I am connecting, executing this drop a table if it exists, creating the students table. And this is what it looks like. It has an ID, a name, and a favorite food. And they can all be null. I'm not too worried about that right now. Then I execute that query. And then once again, I'm executing a query where I'm inserting a single student in with their favorite food, and the ID will be auto-generated. And then we're skipping the rest of this stuff. And then we're coming right here to connection.commit and connection.close, which we'll talk more about that commit later, but we're just, we're actually making it so that it happened, and then we're closing it. So if I run this, I would expect all of that to work. And then I can go into PSQL, and I can go into scopg test. And now that I'm in here, I could say something like /d students, and I would see that I indeed have that students table, and this is its schema. And I could also say select star from students, and I could see all the students, and there's just one Alice whose favorite food is cake. So everything I've shown you so far is enough to do everything more or less, as in you could just, all you really need is connecting, executing, and you could execute any statement just like it was in a .SQL file. And then finally you commit and you close. That's all you really need. But as you might imagine, if we're inserting into over and over and over again, that can get tiring. So this is where it actually gets kind of useful to say something like, let's use Python. So in this case, I'm saying, okay, let me create a function, a Python function, and it's called insert into students, and it takes two variables, name and favorite food. And then I write this query, which the query is in F string. So I'm actually able to put variables right into it. And the query is going to look like insert into students, name, favorite food, values, name, and favorite food. And notice that these are strings, but it would just put the string in itself. So we want to wrap it in single quotes to make sure that it actually, sees it in a way that is SQL appropriate. And then finally, we're going to execute that query. So now I can just call it like this: insert into students Bob Lemons and insert into students Carol Tuna. And then once again, I'm committing and closing. And just to see what this actually looks like, because it is Python, I could just print it. So I'm going to print that insert query when I run this code. So now I can actually run the code, and it's still connecting to, PSQL. So it's going to, oh, oops, that's not what I wanted to do. I'm going to run that Python code. So this is what these, queries look like. This is what was produced from that function, and that's exactly what we want to run because that's valid SQL. And then once again, I can go into PSQL, and I can go into my database. And now in my database, if I said select star from students, I have multiple students in there. So you could start to see how we're doing this thing where we're utilizing some of the features of Python to make our lives a little easier in terms of writing SQL. And then we're going to take questions in a second. But the first thing, or the last thing we want to show you is this. So I'm going to uncomment this out. I've repeatedly been going into PSQL after I run this code. Let me take the print statement out. I've repeatedly been going into PSQL after I run the code to check my results, but I can also do that from Python with scopg. So now I'm running connection.execute, and I'm executing the select star from students. But of course, it's not, if I execute this, it's going to print some stuff out. But what it prints out is not something that I'm going to see. If I didn't have this here, if I just executed the statement, so I'm going to take that out for a second. If I just executed the statement, it runs, but I don't see anything. And if I looked in the database, it would look correct. But this executing select star from students doesn't actually do anything that I can see. So that's why I actually can store the results of it in a variable. And I'm going to take this part out for a second just to see what does it look like if I try and print the results. If I do that, well, I get this, weird looking object, not so easy to work with. But if I add this in, so there's a built-in thing, this results thing, I don't know what that is, cursor, tuple, row, but it's something that, you know, references that entire table in our, you know, it represents the entire table that our select statement returned. But now I can call this dot fetch all, and it's actually going to list it out. So now that if I run this, I'll see it's not exactly what you might be used to, but this, you know, it's not exactly, it doesn't look like a table, but this is all of our data in tuple form. So this is our ID, this is our name, this is our favorite food, and it's a list that contains, you know, each tuple represents a single row, and each column in the tuple represents a column in our table. And so in this way, I don't actually have to go into pSQL to look at my results. Okay, so let's discuss this part.
Are you opening the floor for questions?
Yes.
For the connection.execute, you're putting stuff in like triple quotes. Is that necessary?
Right. So it's not necessary. As you see here, I'm just doing it in regular quotes for some statements when they're on one line. And because it's Python, either will work, whether I do single or double quotes. I just default to double quotes. The only reason I'm doing the triple quotes here is because by the nature of Python, because it's white space sensitive, if I tried to do this on multiple lines with single quotes, it doesn't like that. It doesn't understand it. So Python's solution to multi-line strings is the triple quotes. That lets me put my strings on multiple lines, and now I can write it in a way that is maybe more readable for me. And then again, you'll notice here, just like a regular string, these triple strings can have an F in front of it. And if there's an F in front of it, that means now I can do this feature where I can interpolate a variable into a string. So the value of that variable, which is assumed to be a string, is going to be placed directly into this you know, string that we're creating.
That makes sense. Thank you.
Cool. Any other questions about this, what we've taught so far in this? And I know we've gotten into this habit of, you know, taking, like, I've heard that it's a desire now to spend some time in class where we just give you like 20 minutes to like work on what you've seen. So if there's, we're going to continue to ask for questions, but after this, I think let's take like 20 minutes to just write something like this ourselves.
So what I think is helpful, if you don't mind me saying, kind of like in the workshop, every time that we went through something new, they had like a small little exercise where they'll give us like 2 or 3 minutes to work it, and then we'd cover it. So for example, it'll be like, all right, now that you guys learned this, go ahead and add this info into the table, and then we'll like practice doing it. I feel like that really helped learning the material.
Yeah, for sure. Yeah, I mean, that's in my opinion, that is the better way to do things. The only reason it's not done that way right now is just because the curriculum doesn't look that way right now, and so rewriting it takes time. But would it work if I said like, you know, take this code and then can you use it to like insert, you know, a few more examples, or can you use it to run another select, but this select would have like a where statement in it, where maybe you were looking for everyone whose favorite food was tuna.
Yeah, that's pretty good.
Okay, so how about that? This I can share this, but it is actually, if you look in, I think students.py is a little more filled out with, no, students.py is exactly it. So this already exists in students.py, assuming, so the I'll say the task right now is, assuming you have access to all this stuff, one, create DB with a given name, default, sci-cop G test. And then 2, successfully run students.py, which might mean you also need to get your like if you're having trouble just installing scicopg, which it looked like some people had, that's where you would get to this issue. After successfully installing it, I'll say the next thing you're going to want to do is maybe let's say, no, I'll say let's leave the query exactly as it is. Let's leave the schema exactly as it is, but let's insert another 2 examples, or, you know, insert a few more examples into the DB using this function, insert into students. And then finally, 4, write and print a select query to find all students whose favorite food is tuna. So you would probably want to insert a number of students, including some, you know, with repeats of the favorite food or whatever the favorite food is. So let's now spend the next, you know, it's 9:37 at my end. So let's spend the next 23 minutes working on that, and we'll come back at what is 11 a.m. CST. Does that work?
Yep.
Ben, could I ask you a quick question?
Yes.
Related to the virtual environment stuff. So I'm figuring out now that I didn't have the install fest thing done right for the default virtual environment the whole time. Is that going to be a big deal? I ended up fixing it, but
not necessarily. I can help you with that. I think maybe it might make sense for me to open up breakout rooms, and then everyone can work in a breakout room right now, and then I can join a breakout room if it's desired. Does that make sense?
yeah, I mean, I think I got it fixed now. I'm just wondering if all the work I've done up, I mean, it seems like everything's still the same. I had like a misspelling in the ZH file, and I just fixed it. So now it's constantly in a default environment, but it wasn't before.
Okay, well, I think what I'm going to do, I just open the breakout rooms. People don't need to move into the breakout rooms, but I imagine that during this thing, I want to leave this up. So everyone should continue to see this, but I want to be able to take breakout rooms. In fact, I'm going to put this in Slack so you could see it, because I think it's going to disappear. Don't look at anything on my Slack right now. Just sharing this, what I want you to do. It's in the Slack now in the uniform channel. I'm going to go into my personal breakout room. And so for the next 22 minutes, work on this to the degree you can. But if you have questions, including questions like, how do I get my virtual environment stuff set up? You can come to the breakout room and my breakout room, and we'll work on that. Does that sound good?
Yep.
Okay, so I'm going to go into my breakout room, and if anyone wants to discuss something, please find me.
I don't think breakout
They're
rooms
not
are
open for us. Yeah.
Really? It says, oh, it's because everyone's unassigned. I seriously don't understand how Zoom works. Really, it says breakout rooms are open from my end. Do I have to hit broadcast? No. It says you're all here, but you're unassigned. I guess I would have to assign you. You guys can't see breakout rooms?
I know Jonathan Moya, he's the expert on this. Is he here?
Yeah, I'm gonna try closing all the rooms.
I'm here.
Yeah, what do I have to do to open breakout rooms such that everyone can see and enter into the breakout rooms?
There should be like a little drop down menu at the bottom left where you're trying to do the breakout rooms,
Mhm.
and I think you have to click one of the options. I don't remember specifically which one though. But there should be an option there that allows users to join rooms.
I see. Allow participants to join rooms. Very good. Okay, so I'm opening all the rooms again, and you should be able to join the room now. Does that make, can you?
Yep.
I can see it now.
So I'm going into my own room right now, and yeah, you can go into your groups if you want to work in groups on this. And I'm going to go into my own room for questions. So I'll see you all in a minute. Hey, everybody. So yeah, question.
Hey, I'm just trying to figure out if I ever set up like the default environment, just because I tried to find like the default file just through Finder on Mac and like nothing came up, so
Yeah.
I don't know if that means it's not installed.
Okay, well, let's figure it out. I would say first share your screen if you can. Okay, so let's, oh, I like your that's a really cool terminal coloring thing. So I would say first go to your home folder.
Okay.
Which you could always just do like CD squiggle and you'll get all the way there.
If you just do CD too, it takes you to the output.
Oh, that too. It looks like just CD is enough. Okay. So now from there, can you LS for us to see if you have anything like this default thing? It looks like you don't. And are you using Z Shell? Or sorry.
I mean, this is just I was using like, yeah, it's like the Z
Wait,
shell for
is this supposed
Mac.
to be in the root or the home folder? Or root folder or the home folder?
You want to be in the home folder, not the root folder.
Oh, I was looking in the root folder earlier, not the
Yeah.
home folder.
You generally don't want to be in the root folder for most things because you, as a user of your computer, don't truly have access to the root folder. The root folder is Apple. And so it's always going to kind of yell at you and make your life hard and ask you to use sudo if you put things in the root folder. But we totally have access to the home folder. So the first thing we're going to want to do is we're going to want to create this default virtual environment. So we're going to type Python space -m. I don't know what the -m is, but -m, and then VENV. It's like virtual environment. And then the name we want to give this virtual environment, which I'm going to say, let's give it the name default. Yeah. So hit enter. And after a second, it's done. Now, if you type ls, you should see a folder there called default, and we do. So now to test if it's working, let's type source. And then we'll go into a file we want to run in default. So we'll type default, no space, / and tab is helpful for this. So if you hit tab, you should be able to write. We want bin. So bin means like binary. It means, programs you can run, and then activate. So just regular. Yeah. Okay. And hit enter on that. Great. That means we are in the default environment now. And if you typed pip space list, it would tell you all of the things that pip knows about in your default environment, which looks like not too much. It's telling you can upgrade pip if you want. It's not super necessary, but maybe you'd want to do that eventually. Okay, so now that we've done that, the thing is, if we were to exit and reopen our shell, it wouldn't remember it. So what we want to do now is open up, because you're on a Mac, I think I know what shell you're using, but actually type out echo, ECHO, space, right? And then $, all uppercase shell. And that'll tell us what shell we're using. We're using Z shell. Okay. Which means that we should have a hidden file at our root called .zshrc. So let's open that up with code. Let's do code. And because we're already in the root folder, we could just do it like that. Yeah. And yeah. And if you hit tab, is it already there? Like if you take out some of those characters and hit tab, does it know about it? It does. Yeah. So let's open up.
Okay.
Let's open up .zshrc. Okay, and there's a bunch of stuff in there. So let's start scrolling down. We don't, I guess, care about too much of it, but yeah, at the end of that last line, we're going to add another thing. So go past that line, go another line, I would say. Let's add a comment now. So let's do hash and then space, and then just write like, activating default Python virtual environment. It doesn't really matter what you write here. It's just for yourself to remember. And then on the next line, you just write exactly what you wrote before, which is Python or source default /min/activate. But importantly, you have to tell it, so source space.
Oh, space, okay.
Yeah. But it actually, so yeah, let's just write this first, the default /min/activate. But the thing is, when you write default /min/activate, it's not going to know, I don't believe it's going to work. I actually wonder. I think you have to put a squiggle / in front of default so it knows where you actually are. I think that's what I have in mine. So, and then a / after the squiggle. So we're saying go to the home folder, and then this is the path to activate, and then hit save. And now you're going to want to close your terminal and reopen everything. So I think actually, if you're going to be doing it in Visual Studio Code, you're going to want to hit the trash can on the right, because otherwise you're closing the visual of it. So you see that trash can? Yeah. So now we really closed it, and now reopen it. Okay. So now it should have ran that .z_shellrc. So now if we type, well, we haven't installed anything, so we don't know. But if you type pip install scopg, okay, hit enter. I think maybe what we want to do here first is run that pip install -- upgrade pip. So you see that line it's telling you, so let's do that. So and then after this, I think we want something like pip update. So I think the issue is that it doesn't know about this formula. Maybe it's not update. How do I, does anyone know? No, it's something like, let me just search myself quickly. There must be some way to say pip. I want all the, I want you to update your list of packages. Maybe you don't have to do that. Yeah, let's try that again, the scopg thing, but I don't know why it didn't work the first time.
Because like I did do this like as I was like following along with the other one, and like it worked just fine.
What if you type like pip search? Is pip search a thing? Like if you try doing pip search scopg, does that seemingly come up with anything?
I guess you can't use search. I don't understand why it's like doing that, because like I could run like scopg like as I was like coding along with the examples. So, or do you think it's because of the upgrade?
I'm not positive. It
So I
doesn't.
was following along the whole time because I also did not have the default profile, and pip install scopg worked fine.
Okay, yeah. So I guess it just, if you don't have a default, it just installs it for the whole system in some way. Like it has its own version of default, which makes sense. But still, I'm surprised that it can't find it now. Um,
Was I typing it wrong?
I don't think so.
Yeah, you
Yeah, I
were
was. It was
Oh,
you
you
had the
were?
Y before the
ESY.
S.
Oh, I see.
Okay.
Yeah, that's the
All
issue.
right.
That is one of it's kind of a flaw of all this stuff that like search, whatever it is, won't work if you got like a typo. So yeah, let's try it again with pip install scopg.
No, that did work.
Oh, you got it. Okay, great.
Yeah.
Now that you have it, if you type pip list, it should be there. And then once again, if you were to trash the terminal and reopen it, just to make sure, now if you reopen the terminal, you should still be in that default. So if you say pip list, it should still be there.
Okay.
Cool. Yeah. So that is what you would want to do. Yeah.
Is it showing that you're in the default, Della?
Mine doesn't
This is
have like
showing.
what Ben has.
I don't know
How can you
why.
show that you're in the default with your terminal?
Mine does.
Mine does, but I
yours
just don't
too.
see it on Della's.
I think it's because she's using a special, like I saw in her Z shell RC, she's using, it's doing something because she's using some unique terminal, right?
Yeah, it's like I could probably look it up on like Starship how to add that in so you can see the default.
Either way, there's probably a way just to say like, I'm going to search for it myself, like Python, what them am I in? Like there should be a way just like PWD is print working directory. There should be an easy way to just print what is my current virtual environment.
So I got a question about all this. I follow along. I have the default thing now. I added the, source default bin activate to my bash RC and bash profile because
Someone said it.
And it all works. But I'm just curious, what does this change?
The
Like,
virtual.
so like is there going to be stuff now that I need to reinstall on this virtual environment? Am I still going to be able to access all the files that I've been accessing? Like, I'm just curious as to what this changes.
Yeah. So what this does is that if you're not, I believe if you're not using a virtual environment at all, every package you download is downloaded for your entire computer. So instead of a virtual environment, your real environment, your laptop, that's where all the dependencies get downloaded. And that means there can only be one version for each dependency. And it means that all the dependencies, like Python is aware of all the dependencies at the same time. This virtual environment stuff is just to say for a specific project, if I want specific dependencies and only those dependencies, or if I want a specific version and I might use a different version on a different project, the virtual environment is like you're creating a little bubble for that project. And you say, for this project, we only care about these dependencies, or we care about these versions.
So far, what dependencies have we installed that I may just want to uninstall and then reinstall on my virtual environment?
I wouldn't worry about it. Basically, if you run in, because I don't think we have installed much. We will start to a little more with Django. But basically, if you're on a given environment, a given virtual environment, and you want to be on that virtual environment, and you try and run your code and it says, what library? I don't know that library. Then you type pip list, and if it's not there, then you say, oh, well, it's not here, so that makes sense. And then you install it, and then you installed it for that virtual environment. So it's not the kind of thing you need to figure out ahead of time. It's just, if you don't have the dependency because it's not associated with that environment, then you download the dependency.
Could we see someone's pip list that has had the default environment the whole time and has installed everything on there so that I could see and can like cross-reference with my pip list, and anything that's not on mine I can install just so I don't have any problems down the line?
Yeah, I mean, you could see mine, but it's going to also include things that, because I'm just using this as my default, it's going to include things that only I used maybe for like personal stuff. And so looking through it, there's at least like 50 things on it.
Oh, okay.
Yeah.
Oh, Ben, also for the version, for any Mac users, if you type pip dash capital V, it'll pull up the whole like file, and you can see you're in default, that default file.
Pip dash capital what?
Capital V.
Capital D.
V as in Victor.
Ah, got it. Victor Platoon. So when I type pip space -v, it's telling me, right, exactly. It's showing me the version of Python I'm using, or sorry, it's showing me the version of pip I'm using, and the version of pip I'm using is actually unique to my environment. So it's in the default environment, exactly.
Suhail, your .bashrc should be in your home folder, but you're not gonna be able to find it with ls. You have to do ls tech a because it's one of those like hidden files.
Gotcha. Okay, yeah, I'll just CD into it and input that line. Thank you, Michael.
Yeah, well, I pull up in code, so I go to my home and I do code space .bash rc with the little tick between bash and rc, and then you can just use VS Code to input it in.
Okay, gotcha. Thank you.
Yeah.
So
Okay.
Ben, you were saying to like Michael's question, pretty much it's like having this environment wouldn't really affect anything because we haven't really used it yet, and it's more of like a, you know, case to case basis when you're creating like a different environment.
Yeah, that's what I'm saying. Yeah.
Okay.
It's not something you have to worry about so much. We're trying to introduce it because it matters in the real world eventually, because if you're working at a company, you're probably not working on just one project. It's probably like, oh, we have the marketing site and we have the internal site and we have like the web app, or sorry, we have like the, you know, the phone app or something. And those are all different projects, and maybe they're all using Python and they all want to kind of keep their dependencies separate because it's as if they live in separate worlds. They want to be on separate computers with separate dependencies, and that's how you accomplish that.
Okay. It's pretty much so like the code doesn't like overlap with one another as you start using like SQL or other databases.
Yeah, I mean, this is a relatively large problem in all of computers, which is how do you make it so things don't overlap if they share the same computer? And there's increasingly sophisticated solutions to that, where I know someone mentioned in the chat, the modern solution is what's called Docker. And how that works is that instead of saying, oh, I have a, you know, this folder is a virtual environment, you actually use this thing called Docker, where you say, right now it's as if I'm on a different computer. So, you know, each of these three projects, they're on different computers. So of course their files won't conflict. When we get into the JavaScript stuff, you'll see that JavaScript does this a little differently, and I prefer the JavaScript way. It's just all based on a folder. You don't have something like a virtual environment. It's just every project is in its own folder, and every project has a folder called node modules, and that's just where all of the dependencies for that project are saved. And in a different project, it will have a different node modules folder. But yeah, it's definitely not the focus of today's lesson, which I think if I were to fix this lesson next for next cohort, I think we should take that, like the virtual environment stuff, we probably shouldn't introduce it until we really have to, and then we introduce it well.
Do you mind if I just share my screen and show my bash RC, my bash profile?
Yeah, go ahead. Yeah.
So that anyone who needs to see that.
Mm-hmm. And I think we're going back to the main room in a second. I'm sure most of you did not have time to do the little breakout thing, but someone's a Dark Souls fan.
Oh, yeah.
Actually, I booted up Elden Ring for the first time in like 6 months the other day, and I was like, oh wow, yeah, like I could play this game for another like 80 hours and not be finished, but I never got that far.
Yeah, it is definitely a good game.
I beat the first Dark Souls. Very proud of that. Never beat any.
Oh, I love the first Dark Souls. That's my favorite one. Okay, I got both. Let me just pull this over here. Okay, so the only reason I put in both, so I have in my bash profile and my bash RC, because when I normally open up my terminal, it reads my bash profile. But when I open up my terminal in VS Code, it only reads my bash RC.
Interesting.
So at the bottom of my bash RC, I have my aliases and I have the source thing. And then in my bash profile, I have my aliases and the source thing,
Yeah.
and my CD to go to home. But
And
I
there's
just have
actually there's a simple way that you can combine these, as in instead of copy pasting everything from one to the other, you see how we're like for the default environment, you see how we say source and then like some file. That means run that code. So basically in your .bash profile or in your .bash RC, whichever one it is that you want to run the other one in case it doesn't run it, you just say source and then the location of .bash RC.
Yeah, I heard someone say that online as well, but someone else was saying there's a reason they're two different files and you don't want one to just always read the other for like
Okay, that's
certain
fair, yeah.
cases. So I
That's
didn't want
fair.
to do it just in case I run into an issue.
Yeah, no, that seems appropriate actually. And if you scroll all the way to the top, it looked like there was a comment that implies the difference, which is that .bash RC is executed when you're using bash, but you're not logged in. So I guess VS Code, it isn't logged in as your user or something. It's separating those environment for the sake of, it's probably because you didn't click the part that says like this is safe, you know? Like you saw pop-ups in VS Code that say like, is this safe?
I think I did. I don't think I put to remember my decision though.
Right.
I think I
Whatever
just clicked
whatever it is, I'd say if people said that online, I would believe them that you want to keep them separate for whatever reason.
Yeah, I just don't want to run into any edge cases that screw up something.
Yeah.
But yeah.
Like everything with computers, it's sort of like you live and you learn. Like if you did do something and it was some big security flaw, you would find out when you did it at a company and you blew stuff up, which obviously isn't the best way to learn, but like I feel like making sure, like just getting things to work is step one and doing it right is step 100.
Yeah. Did you get this, Javale? Are you good?
Yep, I'm good. Thank you, Michael.
I'm going back to the main room right now, so I'm leaving the breakout room.
Okay.
We're going to start again. Hey, everybody, we're back. I think I'm going to pull everyone out of the breakout rooms now. So the breakout rooms are ending and everyone's coming back. Hope you guys had some time to work on it. I know some people were in the breakout room, my breakout room, talking about the virtual environment stuff, which I know threw people for a bit of a loop. And it's not super relevant to today. So really, we just shouldn't introduce it right now. It's just that we have to introduce it at some point, and it was in the curriculum doc already, but it probably should be moved because it's not necessary for what we do today. So people should be coming back. Does anyone want to share what they worked on over the little period of time we did stuff? There it is. Pete, you want to share?
Yeah, I could share mine.
All right, so share your screen.
All right, so yeah, I just added some more students. Line 38 through 43 here. Added a few more tuna lovers. And then I'm gonna skip down here. I did a select statement here. I did tuna finder equals connection.execute. And then I just did a select from where favorite food equals tuna. And then I printed the tuna finder with fetch all. I'm gonna comment this out and then I'll just run it.
I think you're gonna have an issue because you commented. You need to comment the next line as well.
Oh yeah, thank you.
Although it looks like that does the same thing, right? You're just kind of separating them. Yeah.
Yeah. Yeah. So then I got all the people whose favorite food is tuna. And if I comment that one out, I try to create a function where you kind of have the freedom to insert which favorite food you want to find from those students. So just to find a function, find students by fave food. You can insert a food. And then I did set find query equals to the F string that has a select from students, where favorite food will kind of take that input for favorite food. Then I returned executing that find query with the fetch all. And then on line 52, I just printed it to see what the results are. So I could run that. And we get the same thing. But then I could also put in like lemons, I think was one.
Yeah. You only have one for that, but yeah, exactly. It will work.
Yeah, so then we got Bob lemons.
Yeah.
Yep.
Yeah, no, that's great to see, because that's the real power of using, like, there's no reason to use scopg if you're just going to be writing queries. You could just as well use a .SQL thing, but the fact that you can now create a function and say like, well, I don't have to rewrite all of that just to change the favorite food. The favorite food is now a variable, essentially. That's the real power of using a programming language with SQL. So cool. That's exactly what we wanted to see. So let's just quickly look. I'm going to share my screen again. And where do I have the stuff? I have everything here. So I'm going to close this for right now. I guess I'll close this for right now. Opening back up this file. So where were we? We've done this stuff where we've shown how you can, like, make this function for the sake of inputting things, and that's really cool. I'm realizing we only have like 50 minutes left, so we really should run through all these ideas that we have left, because there's a few of them, and I guess I got a little sidetracked with some questions early on. But yeah, so we're going to discuss what that commit thing is now. So in SQL, not just in scopg, but in SQL, there's this idea called a transaction. And a transaction means that you can sort of set up multiple, just like a transaction in the real world. Like imagine you were on like a banking website, because this is the example we're going to use. So let's say you're on a banking website and you want to transfer money to somebody. Well, that would probably happen at some level in a database, but it would happen in two steps. First, it would be like, oh, if I'm trying to transfer money from my account to your account, first I would subtract $100 from my account. Then I would add $100 to your account. And the nature of a transaction like that is that if I subtract $100 from my account, I definitely want it to go into your account. If something goes wrong, if for some reason the second part doesn't work, I shouldn't lose $100 and then it just disappears, right? So a transaction is like the idea that there's multiple things that have to happen, and if any doesn't happen, we don't want to complete the transaction. And if we didn't have this idea of transactions, every time we did execute, it would run that line. And so if we executed, lose $100, and then that worked, and then we go to the next line and we say, and now add $100 to this other account. If that didn't work, well, there would be no way to recover it. We would say, well, I guess he lost that money, even though it didn't go anywhere. And that's actually something that is built into SQL, even though we haven't covered it. There's this begin transaction. There's a commit keyword. There's a rollback keyword. We're not going to teach that in SQL, but we will teach how you can do it in scopg, because it makes it a little simpler. So we have this accounts.py file. Let's look at that. I have it over here. And the accounts.py file is not too dissimilar from the other one. First, we're going to connect, we import the library, then we connect to the database. Then I'm going to say drop this table accounts if it exists, and otherwise I'm going to create what an account is. Has a ID serial primary key, it has an account name, and then it holds onto a balance, which is an integer. And maybe it would make sense for it to be not null or for a default of 0, but we're not too worried about that right now. And then I execute the query to connect the table. And then I'm going to create this helper function insert into accounts, which takes an account name and a balance. And then it's going to insert into accounts a new account name and a new balance. And then we execute it. And then I create two accounts, one with $100 and one with $0. And then we're going to select all and print it. And then once that's done, we're going to commit, which means that all the things we executed up until now, including the select, now they're going to officially happen. So in order to make that happen, the first thing I'm going to do is I'm going to comment out all of this. And I'll just leave this last one in there, connection not closed, because we do want to close it. So now let's actually run this and see what happens. So I'll do Python accounts.py. And indeed, I have something with my account has 100 in it and your account has 0 in it. Okay, so that worked fine. But now what happens if we want to make a transaction that could fail? As in there's two steps to it. I take money out of my account and then I add money into your account. And the reason we are going to do it the way we are, let me get that right. The reason we're doing it the way we are is because even though we're just doing it on a local computer right now, because we're doing it on our local computer, it probably can't fail. We already connected to the database, we're good. But let's say we were connected, this database wasn't, just connected to localhost. It was actually on a computer somewhere else. So it depended on the internet. Let's say we executed that first statement. So we're gonna execute this statement, update accounts, the account with my account name, my account, we're gonna subtract 25 from the balance. So that could work. And then right after that, we try and do this other one in which we add to someone else's account. But let's say the internet went out, it's not working anymore. There's a timeout. So in that case, we wouldn't want to have actually, committed this minus 25. So that's why we're going to throw it in a try except block. So the nature of the try except block is that it's going to try something. And if a exception is ever raised, then we go into the except block down here. Otherwise, it never happens. So we're going to try something. What we're going to try is transferring money out of my account. So first we do this, connection.execute. And notice up here, we already committed. So we already committed everything up until that point. But here we're going to execute update accounts where account name is my account and set the balance to whatever the balance is minus 25. So if it was 100, now it's 75. And then we'll ignore this part because it's commented out. And then the next thing we do is we say, okay, and now also update accounts, set the balance to balance plus 25 where the account is your account. So your account should go from 0 to 25. And because we got this far, because they both executed successfully, and notice that even if we don't raise an exception, let's say I wrote something incorrectly here, that would also raise an exception. So if I just had bad, if I had like that wouldn't make sense. SQL would blow up and scopg would, I'm assuming, throw an exception to say that didn't work. But this will work. And then because it worked without error, we got to the end, we commit it, and we're done. And we're not going to look at this part yet because we haven't encountered it. So now we just, do results equals connection.execute select star from accounts again, and we print it. So now when we run this, we'll see what we expect. As in first it was 100 and 0, and after the transaction happened, it's 75 and 25, right? Cool. So now the question is, what happens if we throw an exception? So we're in this try block. Let's say up here, something went wrong. We lost our internet connection. Something went wrong. We don't know what it is, but for whatever reason, this try block cannot finish getting to the end because something raised an exception. So what that means is we don't even run this next line, right? But we've already run this line, connection.execute. So we've already theoretically, even though we haven't committed it, we've taken 25 out of that, the account, my account. So we raise the exception, oops, And that means we jump down here to accept exception. So the name of the exception matches. We don't really care about what's in it right now, but it's the same kind of exception. And then I might print something, query failed, roll back. And then I'm able to do this connection.rollback. And what that means is basically whatever you have that you've executed, but you have not committed yet, just throw it away. So that's just like typing like git reset or something. You're saying whatever my working changes are, I don't, whatever I committed, I want to unstage it because, something went wrong. I'm not ready. And then finally, we're going to print it out, because this is outside of the try block, we're going to print it out and then close it. So now let's try running this. Okay, cool. So it looked like this. Then we tried to subtract 25, but we don't actually see that. Instead, query failed, roll back. And in its final form, it's exactly like it was when we began. So that is what committing is, and that is what the concept of a transaction is. So let's open the floor for questions about that. Does anyone have a comment like, yeah, that makes sense, or no, it doesn't?
I think it makes sense. We hit transactions a bit on Friday.
Oh, cool. That's good. Yeah. So yeah,
So,
go ahead.
so the only difference with doing this in Python and doing this in SQL is you don't use begin in Python for a transaction because you still use commit, but you don't use begin, right? In this, or you don't need to.
You don't use what?
Begin.
Yeah. So, right, exactly. So basically, those keywords like begin, transaction, and things like that, the keywords, you're not actually writing them in SQL because PsycopG is kind of doing them behind the scenes for you based on, I think everything you do in PsycopG by default starts with begin transaction. And then it's only once you do commit that it commits that transaction. Otherwise, if you do rollback, it rolls back that transaction. So this is getting us closer and closer to what we will see in Django. But we're more and more replacing writing SQL directly with writing some kind of Python code that behind the scenes is still SQL. But we're working with it in a way that is more compatible with Python. Okay. So are we good on that one? Because if so, we can move on, because I just want to make sure we cover everything in the time we have. Okay, so that was the idea of a transaction that we just covered, which the whole point of it is you can follow this pattern with the try except block and with the rollback in the accept case. You can follow that if you're doing a number of things where if one of them fails, you don't want to do it anymore. You want to make it so that it's only if all 4 steps happen that you count any of them, because if it failed before all 4 were completed, you want to roll back the last possible 3. Okay, so the next thing, and this is another small thing, we don't need to spend too much time in it. We saw this try except thing, but it can be somewhat tedious to do it that way. And so part of what we can do is use this with keyword in Python. So the with keyword in Python defines a context. And you might have seen this already with files where instead of opening a file and then later remembering to close it, if you use the with keyword, you're sort of registering something that you're saying, I'm opening it and you know how to close it when I'm done. So I don't need to explicitly remember to close it at the end. And the code for that is here in contextmanager.py. So I'm importing PsycopG like normal, but then over here, you'll see I have the with statement. And the with statement connects to scop G. And then we actually pass it the second thing, auto commit equals false, which I think just means what we want it, how we want it to be, which is when you execute something, it doesn't actually execute it until you explicitly commit. And then we have this as connection, which means that this thing over here, the with, whatever is returned from it, we want to keep it around as a variable called connection. So within this with statement, you'll see that's the rest of it. Within the with statement, I do things like normal, connection.execute, drop the table, create the table. And this is the same example of this account thing. So I'm creating the table here. I wrote this logic to insert new things into the account, and I insert the new things into the account. But notice I didn't commit here. I suppose I could have, but the nature of this with is saying it's only if all of this passes that I'm going to do any committing at all. So I suppose I could have moved some of this logic outside, but the with thing is saying this whole thing is a single transaction, and I'm going to, if it fails at any point, it's as if none of this happened. So here we create the two accounts, and then here I'm saying, minus the 25, and here I'm saying add the 25, and then here I'm printing it. And notice that when I'm done, I'm not saying commit ever, because by the nature of it, it's built in with the with statement. And then also I'm not saying close the connection. So unlike in accounts.py, at the very end, I had to close the connection. I don't have to do that if I'm using with. It's built in. It understands that if this is how I opened it, then there's this equivalent thing called, dot close that I run at the end. And if I run this code right now, this should work exactly like the previous code. So I'm going to do that. I'm going to say Python. And then I call this context manager. Okay. And this got me my end result. I suppose I could also have done that first one where I said this results fetch all before we ever did any of the executions. I could have wrote that here as well. And then we would see both of them. We would see the before and after. But notice now, if I do this, if I say raise exception, oops, I don't have an except block anywhere, but you'll see it's graying out the rest of it. And what actually happens? So now I'm going to run this. What happens? Well, it's saying that we raised this exception. Oops, we're printing the exception, but none of that other stuff happened. And that actually makes me wonder if I go in there, has any of the previous stuff happened? I don't actually know. So if I say PSQL scopg test and I say select star from accounts, right? Yeah. I think it is this way because it rolled back everything, and this is how it looked when I finished the last time. So let's just say I'm just gonna run this code like this. It's gonna be 100 and 0, and let's say I don't do any of the rest of the stuff. So the rest of the stuff here is getting commented out. So now this file is a with. It creates the account and then it inserts 0 and 100 into it. So let me run that. It works successfully. I go in here, I look at my accounts. That's what it looks like. So this is the current state of the database. And now I'm going to add this stuff back in. And the way this works now is it's going to drop the table if it existed. It's going to create the table again. It's going to, insert these two things into the accounts, and then it's going to execute this -25, but then boom, exception raised. So when this exception is raised, it's as if nothing I did in the with statement happened, including dropping the table, including recreating the table. So I'm going to exit out of this and I'll run this code. We see our oops. And now if I go back in here and I look for my accounts, nothing changed. So that with statement is just another approach compared to the try except that will wipe out that basically everything within the with statement. If there's any kind of exception, it's as if none of it happened. And it prevents you from having to write commit and close if you find that to be cumbersome. But it's worth noting that this is just sort of like an upgrade from what we've seen, and what we've seen before would absolutely work. Roger is asking, when do you commit? You don't. As in, it commits when the whole with statement is done successfully. If at any point there's an exception, nothing is committed. It's all rolled back. And by the nature of the with, when the with is done, it will automatically close it. So this with approach is just keeping you from having to write that other stuff explicitly, because that's the behavior you want by default. Yeah. And like a lot of things in programming, it's one of those things where it seems like it's helpful, right? It seems like it's doing more for you, but there are times where you might want more fine-grained control. And so then the verbose way of doing it, where you have to be explicit, is actually preferred. Okay. So any questions about Context Manager? If not, I'm good with that, just because I want to make sure we cover all the other topics for today, which there's 2 more. I'm realizing I need to be more careful about taking too many questions early on, because I feel like we used a little too much time on things that were useful, but not necessarily hyper relevant to today's lesson. Okay, so that's the with statement. Next thing, SQL injection. This is definitely the coolest thing you will learn today. It's definitely eye-opening. So there's a flaw to how we've been using scicopg so far that you probably have not recognized. And in order to see it, let's look at this code here. So imagine I have, the students folder again. I'm going into that scicopg. What is it? I'm going to scicopg's database. I'm creating the table, and then I have this function here, right? And the function will insert a new student in, given a name and a favorite food. And then I add some favorite foods in there. And then notice this, I'm eventually going to print it and then commit and close. But notice what I did here. Instead of writing name and favorite food directly, I kind of split them out, and you'll see why I did that in a second. But this is kind of to simulate how it might actually work in the real world, which while we're hard coding all this ourselves, in reality, some of these inputs, like the name and the favorite food, would probably be inputted on a website somewhere, right? Someone is given a text box. They can write stuff. They can write David. They can write pizza. And then that's passed to your backend through the internet. And then your backend will use those values to try and call this insert into students thing, write some SQL, and add it to the database. So if I run this, it would work as expected. And let me just grab this code right here, because where I'm going to run it is in students SQL injection. And you'll notice this is the same. This is the same. It's all the same, except I'm going to get rid of this part right now. Let's not look at it. And I'm adding this. So, and in fact, I don't have this either yet. I just have insert into students, right? So I'm inserting into students Alice, cake, Bob, lemons, Carol, tuna, and then David, pizza, which I could have wrote in line, but I decided to write it like this. And then finally, I'm going to select all and then print it and then close. Okay, so clear. I can't see my screen because of Zoom. Clear. So let's run that Python students SQL injection. Okay, that's what we expect, these 4 people, right? So now that's a good point, Dave. We probably should change it to tacos because, we want our data to be accurate, of course. Okay, so now David's favorite food is tacos. But what if we're not talking about our David, but we're talking about a really unique David? He has a really cool name. His parents are those people that are like, oh, we're going to give our kid a name that no one else has. He's going to be totally unique. So what if we said, okay, well, his name is not David. It's going to be something like this. His name is going to be, how about this? I mean, this is a valid string, right? David, followed by single quote, comma, cauliflower, and parentheses, semicolon, dash, dash. Seems insane, right? But we're going to very soon see why we feel this way. So we're going to run this now. And let's see what happens. Okay, it worked, but David's favorite food is not tacos, it's cauliflower. Why? This is actually really important. We let's dig in to what we did. So when we say insert into students, it's going to look something like this. Did I write it here? Yeah, insert into students is getting past these two values, right? And then we go into our, we actually go into the logic here of insert into students, and we create this query, which is a string that we put things into, and then we execute it. And remember that SQL does not care about white space. So we're taking this whole thing here. I guess let me actually just create it in a new file. We're taking this whole thing here. It looks like this, right? But we're replacing name with the name we passed in, and we're replacing food with the favorite food we passed in. And then those two values, as we saw, favorite food, it's simple, it's tacos. So I'm just going to replace this, not the single quotes, because those were actually hard-coded, but I'm replacing tacos. And then let me replace the name with this insane name over here. So now we replace it with this name. Okay, what actually happened? You can kind of see from the syntax, because of David's name, we actually wrote the rest of values, and then they cleverly used dash dash to comment out anything else. So it's as if we wrote this, which means this doesn't exist. Everything after the dash dash doesn't exist, and this is what we actually wrote, and that's valid SQL. So it ran. That's called a SQL injection. It's very clever. And while that, maybe that's a little dangerous, like, oh man, this person, made David's favorite food cauliflower instead of tacos, like they messed with our data. So obviously, if the data was important data, like a bank account, it would be a bigger deal. But just to see how much havoc you could cause easily, we don't have to do just David cauliflower. We could say like, oh, this is a bank, this is a production system, whatever it is. How about David cauliflower? Before commenting out the rest, I actually want to do another statement, which is drop table, students. You wouldn't have to in this case, but if they wanted to be careful, they'd say like cascade. So drop the table students no matter what and delete anything associated with it, and then comment out the rest. So now let's try running this. Okay, now it actually breaks, because by the time we're doing select star from students, there is no table called students anymore. So that's a SQL injection. It's basically recognizing that if someone's just going to copy text from one place to another, you can write arbitrary SQL. And that's, theoretically really dangerous. So if we look here, I think this is fun. If you go all the way down, let's go all the way down. You'll see that there's this SQL injection link. And if you click it, it's an XKCD thing. And it's, hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way, did you really name your son Robert? Single quote, parentheses, semicolon, drop. Like this is a classic pattern. Drop table students, semicolon, dash, dash. Yeah, that's his name. That's his real name. Okay, if that's his real name, you messed up from your end building the database. You didn't account for the fact that people could have names that include the words drop table, name of the database. So obviously that's very unlikely. If this ever happens, the person who did it is almost certainly a bad actor, right? They're trying to do this. They don't just happen to have that name. But still, people will do this, even if not because they want some kind of financial gain or whatever it is. If they can do it, they will do it, which means that you at your end as the programmer need to account for this. And the way you account for it is actually pretty simple, and it's why something like scopg is useful versus just copy pasting something into like a .SQL file or something. So I'm actually going to create this new function called insert into students sanitized. And we're going to use this word a fair amount for the rest of the lecture, but Sanitize just means you got it in some form, but the form it's in you can't just use it directly in that form. You have to massage it in some way to make it what you want. So the way this execute function works, you could just give it a query, but you could also do this where you give it a query as the first, you give it like a string as the first input. And the second input, which is optional, is a tuple of parameters. So in this case, I'm giving name and favorite food as parameters. I took them from here and I just passed them in as parameters. And then over here, I have this syntax to say, you know, %s, which is something that, whatever it's called, I keep forgetting, scopg recognizes, which is to say, whatever order these came in, just do them one at a time and place them in there. So when we do this, this actually will help us because now I can do it for the rest of them. And, you know, it didn't make a difference for these, but when we do it for this weird one now, what actually happens? Let's see. Okay, so now, because of the way it saved it, David's name is still David's name. That's what David said their name was. It's just a single string now. It didn't actually get plopped in there like its SQL. Because of this, it was able to understand that whole thing is a single string that fits in there. And then whatever the second thing is fits in there. So it did save it, and it saved it correctly, technically, right? This is David's first name or name, and this is David's favorite food, and nothing weird happened. So of course, if you found this in your database, you'd say, oh, someone's trying to mess with us, not good. But at the very least, it didn't happen. What they were trying to make happen didn't happen. And that's a SQL injection, and the SQL injection is sort of like the mother of all hacks, as in so many hacks start with this as the basis, and it's why you need to know about it. I don't think I have time to read all the quotes, or sorry, all the chat stuff, but there's a lot in here, a lot about sushi. Okay, it's not relevant. So I can explain how the %s thing works again. It's simply this. When I do execute, like if I did this, if I just did execute the query, like if I just gave it the one argument, this isn't going to work. It doesn't make sense because what is %s? It doesn't mean anything. And notice that this isn't an F string. I'm not putting it in the way you do with an F string. But instead, it's a regular string, but you have this %s, which is like a placeholder. And then right here, we say name and favorite food. And the way that works is that this is a tuple. So the first thing in the tuple is going to match the first thing here. The second thing in the tuple is going to match the second thing here. And now it'll work. There actually is a more sophisticated version of this, because if you have a lot of things like this, you might want to actually name them. And in that case, we could do something like this, where we can actually open a parentheses here. And in here, I could say name. And maybe in here, I say food. And then here, instead of doing a tuple, I would actually do a dict. And then maybe I would say, you know, my dict has a key name pointing to name, which comes from here. And now I can actually rename things if I want, where I could say like, okay, I also have a key called food, which points to favorite food. And now this would work as well, where it just matches the name to the name. And not only could I rename it, but also because it's a dict, it could be in the wrong order. So order doesn't matter anymore. And this should still work as expected. So that's what's going on with the placeholder thing.
So this is more like a input validation for SQL to avoid malicious there.
Yeah, the whole reason this idea of the placeholder exists versus using the F string is to prevent this issue of SQL injection. And what I taught you will obviously help in this case, but the whole idea of hacking in general is like the computer always does whatever it's asked to do. It's just a matter of, can you be tricky? And so what I taught you is enough to handle this scenario, but who knows what the modern version of it is. There's probably ways to get around this. And in order to understand it, it requires such a deep understanding of what's actually happening, maybe what psychop-G is actually doing. So it's difficult if you're ever trying to really prevent issues, but it's why security is not something even a senior developer generally is in charge of, because security is a really serious issue that you need someone who is more or less an expert. Otherwise, a little information is not enough. You will not actually help. You will probably hurt if you think you know what you're doing. Yep, go ahead, Roger, wreak havoc on random websites. By the time we get to web development, like front-end stuff, we teach the other major hack, which is called cross-site scripting attack. And that one, you actually could find a fair number of sites. Like if it's not a major site, it will be possible to mess with them like that. The problem with messing with someone with a SQL injection is you kind of need to know a little bit more about their actual database, because like, how do you know what the table is called? You don't know. But yeah, it is. I find this, pretty fascinating. It's a cool thing to learn. Okay, so before we run out of time, where were we? We just did SQL injection. Let me get this back. And we showed how we could solve it. And we also showed that we have this approach where we could actually name these placeholders. And then when we execute it, we could actually pass those names, out of order, or we could rename them. And that's an approach. And that's all building up to what we're going to do now, which is talk about CSVs with databases. So we've talked about CSVs before, comma separated values. It's a common way that kind of any program that works with data can share that data in a format that is not unique to the program. So whether you're using Excel or Google Sheets or really anything, it's going to have this ability to export something to CSV. And that's because CSV is a pretty straightforward way to represent a table, right? So there's obviously way more going on in Excel or Google Sheets than just a table. But if that's all you care about, exporting the columns and the rows, you can do that with a CSV. And we link to it right here, the data set. This is just a data set. The data set is sitting right here, Sacramento RE transactions. But in the assignment today, we do link to where you can download this. But yeah, this is already downloaded. And this is what it looks like. So if you're curious, I'm using an extension called CSV, Rainbow CSV. So it's just a small extension that's going to make it a little easier to read our CSVs, because it can be hard to read. But the way a CSV works is that the first line by default is going to be understood to be the names of the columns. And then every line after that represents a row. And each comma separates, a value associated with a column from the next value. And there's no spaces. So this will be the street of my first row. This will be the city, the zip, the state, number of beds, number of baths, square feet, type, date, price, latitude, longitude. Okay, there's a lot there. And then new line represents, okay, we're looking at a new row now. So this is a nice way to represent this data. And the question is now, how do we use what we know about SQL and psychop-G to take this CSV and turn it into data to actually seed our database with it? So let's look at that. Going back here, the first thing I'm going to do is I'm actually going to create a new database. So I already have this created from my end, but you would create, we could have used a different database that we already had, but we're creating a new database to represent the Sacramento real estate. And we do it like this. We now have something called Sacramento real estate as a database. And just to review, this is how we work with a CSV file. So we're importing CSV, which is a built-in library, not third-party like psychop-G. You don't have to do pip install. It's built into Python. And then we can open the CSV file. So, relative to wherever the file actually is. R means read mode. So we're not going to be writing to it. We're just reading. And then we're calling it CSV file. Sorry. And this is that same with thing because, it's opening a file and then it will automatically close it at the end. And then we use the CSV library to read the file into a dictionary. And now we can walk through that dictionary because it's iterable. We walk through each row. And in this case, I'm just printing one row. And I'm breaking because I just want to see the first row. And if I were to run this, I would see the first row looks like this. So what's important to note is that when we read our CSV file, by default, everything is read as a string, which kind of makes sense because if you look at it, I mean, this is all text, right? How does it know that this is a date or that this is a number? It could make guesses, but it doesn't make guesses for you. It just says, let me assume everything in there is a string, and then you can handle cleaning it up. Okay. So, right, everything is a string by default. And so what we're going to do now is we're going to sanitize the data. So that word can be used in multiple ways, but essentially we're cleaning things up. We're taking it from a raw form and we're cleaning it up so that in its final form, it's going to fit what we want. So here's what our code looks like now, which I think I have just right here, CSV example. So we're going to import CSV and we're going to import scopg because those are the two libraries we're working with. And then there's also these two things that are built into Python, both a library called decimal and a library called datetime. And we're going to grab specific functions from them, decimal and datetime, because these are going to allow us to take strings and convert them to either a decimal or to a date. So the first thing we do is we connect to the database. This is the name of our database. And I'm doing the same thing I've done before where I'm saying drop the table if it exists and then create the table. And this is what I made my table look like. ID, serial, primary key. We don't need to read all this, but basically some of them are strings as we would expect. Some of them are integers. At least one of them is a timestamp. And some of them are decimals, which is to say they're not whole numbers, but they're actually, decimal numbers like latitude and longitude. So we have a couple things here. We have, strings, which some of our things are already in the form of strings. We have integers, which we know how to work with. In Python, we just have int. Those are numbers. We have decimal, which are like floats. And then finally, we have timestamp, which is a unique thing, which is a date. So then we execute that and we actually created our table. So before we do anything like that, we can just see, like if I comment out the rest of this, not doing any of that, and we'll just do something like this, and we're not going to have any yet, so might as well not print it. Let's just see what that looks like. So this should still work in terms of creating the table. So I'm going to write Python, and we're calling this CSV example. So I'll run it. We don't see anything, but if I go into PSQL now, and I want to go into Sacramento real estate, now I can do /d properties, and it's going to be a little hard to see because there's a lot, but I have these different columns. This is what they look like. So I have my ID, it's an integer, right? These all make sense. This is what I defined it to be, even though I haven't filled in anything yet. So I have my table schema there. And if I said select star from properties, I see all the names of the rows, but there's nothing in there yet. So now the thing is, if I come back here, come back to CSV examples, I want to match these data types, but I don't have, I don't know how to do that yet, in that they're not all strings. So before getting to this thing here, the clean data function, let me uncomment some of this. Okay, so what do we have here? Well, we're going to create this clean data function, but we haven't created it yet. But what I'm doing is I'm opening up that CSV file just like normal, and I'm making it into a dictionary, and then I'm walking through each row. And then for each row, I'm saying clean the data. I don't know what that means yet, but clean the data, and then I'm going to insert it. And the way I'm going to insert it is using that approach with placeholders. So I wrote this out, you know, so it would be easier to read. But essentially, these are all of the, it's a normal insert into, inserting into the table properties. Every single one of these is a field or a column in our database or in our table. And then here, I'm just naming all the specific values with their names. And, you know, these all line up. It's a little explicit that we have to do it all like this, but these all line up. And then finally, I'm going to execute the statement in which I match the inserted query to the clean data. And then I'm going to print it. And then, you know, I'll finish up. And let's just see, let's say I didn't do cleaned data there. Like, let's say I didn't run this clean data row. Let's comment that out and just replace it with, you know, instead of clean data, and I'm doing all this with the clean data, I'm just going to put the row right in. So let's see what happens when I do that. Okay, so we're going to run this line. We got some big errors. What happens? So let's see if we can understand this. Yeah, the first place where it blows up is it says key error, street address. What actually happened? It's a little hard to read, to be honest. Query parameter missing. Okay, I see. So it looks like, what's the issue? Well, the issue is that we didn't even get to an issue with types. Instead, I named this street address, right? I'm expecting something called street address. Over here, I'm looking for something called street address. I passed it the row, which, you know, is coming from a dictionary. But if I look at my original data here, the Sacramento, it's not actually called street address. It's just called street. So it's getting confused right there that it's saying you're trying to fill in this thing called street address, but I only see something called street. It doesn't match up. I can't fill that in. So that's where this cleaning up the data thing comes in. So I'm going to change that back to clean data, and I'll comment this back out. And now we actually want to pass that row into a function called clean data. And clean data is going to take a single row, and what it's going to output is that row again, but in a form that matches what our table expects. So that's why we're going to comment this back in. Now we'll open that up. And here's what it looks like. So clean data is going to take a single row. And for some columns, it's not going to need to change them at all. In which case you might say, well, then why are we writing this? Well, because we don't, instead of modifying the CSV row, we're just creating a brand new object, as you could see, or a brand new dictionary, as you could see here. So I'm saying associate in this new dictionary we're creating, associate the key city with whatever the value of CSV row key city is. And now in this case, I'm actually making a change. So I didn't even realize this when I did it. I might move these around to say, right, these are two things. I'm only moving it around for explanation purposes. Like these two things, you didn't change anything. You just set it to the right thing. And yet for these next four, I'm actually saying, well, I have something called street address, and I want to associate it with whatever was in street, property type to type. So the names are actually different here. So I have to set them like that. But then some of them, it's an even bigger issue where I have to say, well, it's not enough to set them number of beds to CSV row beds. I actually have to convert it. So this is just a string. And so let's say I took this int out, right? That's the only thing I'm going to change. I take the int out, and I'm going to try running my code again. It looks like it basically works. But see, that's interesting to me. I didn't think it would work because beds was expecting an integer, right? It looks like let's see if I go into, it looks like Python, or it looks like something in this chain is smart enough to know that when I say select star from properties, which is a little hard to read, that the number of beds, it actually is saving it as an integer, even though I passed it as a string. So maybe that's not our best example. But anyways, it's good to be explicit to say, I do want to call that an int. I want to call that an int. I wonder if it would break if I took out decimal. So in this case, I'm taking a string that looks like this. So my string is latitude, right? It looks like this. And that's just going to count. That's going to start looking like a string. So how do I get it into the form of a decimal number? We're going to see. Maybe this doesn't blow up, but maybe it does. Maybe this one's not smart enough to do it. Looks like it's smart enough again. I think, right? So it does look like, even though I didn't say that latitude is a decimal, if I go into PSQL and I look for it, and maybe to make my life a little easier, because that's a little hard to read, I'm just looking for maybe the ID and the, which one was it? The latitude. Okay. And yeah, it looks like it figured out how to make it a decimal. So that seems like one more thing that turns out it's smart enough to know. I didn't realize this, but I would still have to rename things perhaps, but it's smart enough to know to convert it. But I bet it wouldn't be smart enough to know to convert this, as in sale date. If I look here, sale date is a date like this. It's just going to be a string. So if I just gave it the string, would it work? So let's say I did that. Let's say I said, we don't want all this fancy stuff where I'm saying date time, strip time, and then put it in this format. I'm just going to, let's just maybe take this out for a second and put it over here and comment it out. I'm just going to try and give it the sale date like that. So let's try that one more time. I'm kind of amazed that it all works anyways, which is just to show that whoever made this thought about this stuff. Let's run that again. Did even this work? I don't think so. I am running the right thing. Did even this work? It looks like, maybe it did. Okay. So let's, oops. So let's see that again with going to PSQL, and I'm going to run something like this again, but instead of latitude now, I want sale date. Okay, it seems like it just gave everything the same date in 2018. Is that what the actual data looks like? Yeah, it is. So it seems like that works too, which is maybe kind of silly then that we're showing you that you can convert everything, because you can convert everything. But it's just worth noting that this is part of the cleaning process. So it seems like based on how smart it was, given that we had pretty standard types, I could have just saved myself some trouble by just saying, okay, well, take that original row and just, if it's called city, rename it, or if it's called, street address or street, rename it to street address. Or similarly, I could have said, if I'm creating this table for the first time, let me make it exactly match my row and then, or my CSV, and then I wouldn't have to worry about any kind of conversion. But if you do need to worry about conversion, this is how you would do it. You would just have a function that takes a given row, converts any column name from CSV to your database name, and then if the data needs to be converted, converts them. And while it's been pretty good so far, I'm positive that once we got to like currency or something, it would not just be able to do it on its own. But yeah, and now that we have all of that, we're able to clean the data. And once we clean the data, we can put it in the database, and then it works as expected. So now if we run it in its complete form, hard to see because of the nature of how that stuff prints out, but now it's all good. It's all kosher. So yeah, that is everything for today. Let me look at the chat quickly. I see that it is 11 o'clock, which means class is over. If you have to go, please go immediately. There's no reason you have to stay, but let's just close it up. Any questions about what we've seen with the CSV stuff or anything today?
Ben, it looks like the so in the example where you say it didn't the formatting automatically changed. So this is P-SQL converting the string values that it receives into the decimal and timestamp columns. You automatically converted it into those format, correct?
Yeah, it seems like even if I didn't do this, it's not clear whether it's who's the smart one, whether it's P-SQL itself or whether it's scicopg, but it's somewhere when this query is being executed, it's able to take, you know, some value, and even if that value is, you know, beds and I passed it the string to as opposed to the number to, it seems to be smart enough to say, okay, well, I see that, you know, that field or that column expects an integer. Well, you passed me a string. Can I convert that string to an integer? Yes, I can. So that's enough. And what we're doing here is just being explicit about that. We're taking, you know, we're not doing anything much more fancy. We're just taking a string, converting it to an integer. If it couldn't be converted, it wouldn't work. So if, you know, we had something where the number of beds in our CSV was like the word for, like FOUR, it wouldn't be smart enough to convert that. And so for a situation like that, you would definitely need to be sanitizing it yourself. But it seems like either PSQL or probably scicopg is the one doing it, is smart enough to do the conversion for us for basic types like integers, decimals, and dates.
Got it. Thank you.
Cool. Any other questions for today? Otherwise, we can talk a little bit about the assignment for today. So as you see here, these are the documents, documentation for scicopg. This is just that XKCD cartoon. Chicago salaries is an assignment. I already have this somewhere. I don't want to create it again. But it's using SQL. So if I were to go into regular GitHub, there it is. So if I go into regular GitHub, there's this data portal you can click on and you can grab this CSV file. And then we want you to use the CSV file to first create a database. You can use scicopg to first create a database with, you know, a table, and the table is going to have this schema. And then there's some details here about how you might use some of that data to calculate something like annual salary, because it won't be straight. It won't be like obvious if the person is an hourly employee. And then after you do that, we would want you to clean the data. So make it in a format that actually makes sense. So we didn't give you the types for this, but for some of the types, or I think really only for annual salary, it doesn't make sense that it would be a string. It would make more sense that it's a number. And you don't necessarily have to use, like, Postgres has, you know, currency types, but it would be enough to just assume US dollars and it's a number or a decimal. So we're going to sanitize it. And then from there, just write some queries about, you know, write some queries against the data to find out information about Chicago salaries. So the good thing about a real world CSV is that if I look at this data portal, if I were to view the data, there's going to be so many rows, just so many rows. I can't see how many are in this one thing, but it looks like there's 310 pages of these. So there really are just a lot of rows. But you'll also notice that, like, you know, there's certain things where, like, typical hours is, you know, sometimes null. That kind of makes sense. And while some people have an annual salary, some people don't have an annual salary because they're hourly and then you have to combine their hours with their hourly rate if your database wants to store their annual salary. So we're starting with this data, and there's a lot of it, and that's really useful because we couldn't come up with all these examples ourselves. But what you want to store in the database is going to be slightly modified to represent, you working with this data as opposed to how the city of Chicago stored the data themselves. But that's what we're going to be working on today. And that's it. We're going to come back after the break. I believe we're not pairing today, but hold on for, sorry, I shouldn't show this. Hold on for any feedback on that. But if I look here, it looks like it's solo work time. So maybe not. But I'll get, if we are pairing today, I'll find out, and it'll be in the Slack very soon, and I'll give out pairs, but it looks like it's probably a solo day.
Yeah, it's the group, it's a team work day.
Monday.
Yep, Monday and Wednesday. So pair programming is Tuesday, Thursdays.
Say that again?
The pair programming is on Tuesday and Thursday. So today is just a teamwork. So we have our team that we go into. Usually we have our TAs that kind of help us out, and we just collaborate with each other as a team.
And that's every Monday and Wednesday?
Correct.
Great. I love that, you're really being class president because you know more about how the actual pairing schedule works than I do, as it turns out right now. So yeah, Josh, to answer your question, what you're doing after lunch is you are joining your group in Slack, and we will open the rooms for that, of course. And then you're working with your team to solve today's problem collectively, not as pairs, but as your group. Cool. So I'll stick around for a bit, but the lecture is done for today. And when I get off, I'll upload it. Ivan, I don't think I understand your question. How do you get a markdown file to open in VS Code in? Oh, I think I understand your question.
Yeah, it looks like HTML, and I am,
yeah, exactly. Yeah. No, I mean, so right, this is a markdown file, right?
Yeah.
But a markdown file is not so useful until you read it. So I believe this is built into VS Code at this point. You don't have to download an extension, but you do Command-Shift-P, which like normal opens up the command palette. I believe you could also say there's another way to open up the command palette somehow. View command palette, okay? But the command palette is going to give you kind of every command you could possibly have. And so if I start typing markdown, and that's usually how it works, you type a keyword, you see some stuff. So markdown, there's some stuff. Some of it is not anything I know about, but I could say open preview. And open preview will open it to look much nicer. And there's actually another one that some people like, which is I could say markdown, not just open preview, but open preview to the side. And now I actually see them side by side, and the scrolling will scroll both at the same time.
Okay, great. Thank you.
Cool. And I'll stick around for another second, but yeah.
Hey, Ben, quick question. Yeah, so about the default profile, I know when I'm in the terminal, let's see here. I input source my tac default environment /bin/activate. And then it just has parentheses, my default profile every time anytime I'm inputting anything. Is that just how it should always be, or?
Could you share your screen? It might help me understand.
Yeah, absolutely.
In terms of the chat, in terms of opening breakout rooms, I can do that, but I first need to, let me stop recording now.